Hello. Hello. Good morning, sir. Kishore, sir, am I audible?
Yes, you are audible. Yeah, thank you. Can you hear me?
Yes, sir, we can hear you and see you also. It's clear.
Great.
Sir, we have made you the presenter in the meeting, so you can try to share something, like you can share the slides.
Okay. Okay, hold on. Let's see. Mhm. Can you see it?
Yes, sir, we can see the slides. Thank you, sir.
Okay.
So we will start by 10 o'clock.
No problem. Take your time.
Yes, sir. Yes. Thank
Okay,
you.
I'll stop sharing. I'll stop sharing right now. Okay.
Okay, sir. Okay, sir. Thank you, sir. Good morning, everyone. Sir, it's already 10. So, shall we start with your permission, sir?
Sure.
Okay. So, good morning, all. So, on behalf of all the organizing E&ICT academies at IIT Guwahati, NIT Patna, IIT Kanpur, MNIT Jaipur, IIT Roorkee, and IIITDM Jabalpur, I welcome you all in this day 9 of 2-week-long joint faculty development program on Internet of Things and applications in smart system. So today's first session will be taken our expert, Mr. Narang Kishore, sir. So before we start, we will have a short introduction of our speaker. Mr. Narang Kishore, sir, is technology consultant, mentor, design strategist, and architect in electrical, electronics, and ICT with over 40 years of professional experience in education, research, design, and consulting. Over 30 years of hardcore research and design development experience in solutions, systems, products, hardware, software, and firmware, embedded software across diverse technology and application domains, and over 10 years of consultancy experience to different segments of business and industry. He has over 250 research and design mentees in the electronics, ICT, and STI ecosystems. Professionally, he is an electronics design engineer practicing design and development of a wide spectrum of products, systems, and solutions as an independent design house, Nanix, since 1981. For about last one decade, he is deeply involved in standardization in the ICT and digital infrastructure domain, specifically in critical information infrastructure, including smart cities, smart grid, and smart manufacturing, sustainability, and circular economy. His main focus is on identifying gaps in standards to address interoperable systems and solutions deployments and bring harmonization by defining standards interfaces to ensure end-to-end interoperability. He is leading smart cities ICT standardization in BIS India as well as IEC and ISO globally. After deploying unified digital infrastructure ICT reference architectures in BIS, he is now developing 5G inclusive unified digital infrastructure and trustworthiness, including security, privacy, and resilience. Reference architecture for ICT systems in ISO IEC JTC1. He is mentoring IEEMA Smart Grid Division to develop comprehensive reference architecture for Indian electricity infrastructure, followed by cybersecurity architecture, standards mapping, and compliance testing framework. So with this short word, I would invite Mr. Naran Kishore sir to deliver lecture number 16 on IoT standardization. Over to you, sir.
Thank you very much for such a elaborate introduction. And good morning, friends. I think it's always a pleasure to interact with academia, whether they're researchers, faculty, or the students, because this is the you can say a real focus area for me to share my knowledge. Because if I share my knowledge with the faculty and the researchers, I think you can further disseminate it to the wider community of the students in a much more comprehensive manner. And so I think that is where I'm always happy to be part of the faculty development programs and such events. And thanks a lot for one more opportunity. I think last year we talked quite a lot generally about the IoT, the communications and all that. But this time I think I've been asked to focus on a little bit more on the standardization. But I think before we get into standardization, let's look at have a quick look on the context that we are looking at in the standardization and in IoT. So as we look to the years and decades ahead, tech disruption will be driven by as much by the methods and systems as it is by devices we normally associate with tech disruption. There are several developments that have and will continue to shape business strategies. From automation to sustainability, organizations are adapting to a whole new wave of consumer preferences. And we all know that how this pandemic has catapulted two diametrically opposite paradigms to the focus of mankind: digitalization and sustainability. We saw how digitalization came to the mankind's rescue in these couple of years, whether to give us the business continuity of our personal life, social life, business, industry, and even help us develop the vaccines at the warp speed. But then also in these times when the initial few months when all the countries across the globe are under lockdown, we also saw how the nature recuperated itself, how the gray sky started turning blue, how the ozone layer started filling, and how our in our concrete jungles of the megapolis and megacities, we even started hearing the chirping of the birds, and which had become extinct for last couple of decades. So I think these are a few very interesting perspectives that we need to keep in mind whenever we look at the technology. But I think not getting more into philosophical discourse, let's come back to our main topic of discussion. And today everybody's talking about digital transformation because of digitalization, the impact that we have seen of digitalization in the last couple of years. And what is digital transformation? It's a mix of digital technologies that lead to profound transformation of business processes, organizational activities, and competencies, etc. It's like digital transformation is accelerating impact across the society. So the digital transformation, what it is all about. The society, the business, the infrastructure, and even the services, and all other aspects of civilization on this planet Earth today are going through a paradigm shift in the wake of technological advancements, especially in the field of ICT. All the ecosystems, be it smart cities, smart grids, smart buildings, smart factories, now find themselves making three classes of transformations. First, improvement of infrastructure to make it resilient and sustainable. Second, addition of the digital layer, which is the essence of the smart paradigm. And business process automation, necessary to capitalize on the investment in the smart technologies in this thing. Okay. So, what is the genesis of digital transformation? The digital transformation genesis in any paradigm, domain, or ecosystem is sustainability is its true destination. Resilience is the core characteristics of digital transformation, and smart is merely the accelerator, and standards are the chromosomes of the digital infrastructure that we are trying to build over the, over a period of time, leveraging all disruptive technologies. And what are the imperatives of the digital transformation, the way people understand it? Digital transformation provides a mass market business potential, but depends on open standards to secure interoperability, interconnectivity between endpoints, open standards to secure data migration and decision making towards the edge of the network, open standards to cover industrial domain specific networks and its management and orchestration. Digital transformation is converging OT and ICT technologies together and will require coverage of standards-based specification and open source-based deliverables. Interoperability between standard-based and open source-based deployments will be really critical for a successful proliferation of digital transformation. A unique platform is needed to drive an iterative process to identify stepwise improvement to the specifications or the open source. And so let us take a look at what are the constraints of this digital transformation. Normally, people have been only talking about the IT and OT. But I think now we need to also look at these. I think. Sorry for. Okay. We also need to look at these couple of other technologies beyond IT and OT is the network technology, because they have also evolved into their own, this thing which need due respect and understanding. And then IoT technologies. IoT has become so pervasive that in any use case, it is basically becoming more and more prevalent. Sorry for this over animation, but so. And this artificial, which is again now getting into each and everything. So we need to keep these things in mind whenever we look at the digital transformation. So trying to understand what is digital transformation. It is not a technology. It's a complex paradigm with domain specific implications, because we are today living in an ephemeral world. And digital transformation can mean different things for different stakeholders. Right from, process and IT, field of work and skills, way to work, knowledge management, leadership culture, present, based on whatever you are into, digitalization triggers change and transforms business in whatever domain you may be. So business models are changing. The digital transformation is not thinking about your IT. It is actually thinking about your business model. And there are unlimited business models that you can explore and expand, leveraging the digital transformation. So, because consumer demands today are changing, you remember the days of mass production when Ford said you can have any color as long as it is black. We have moved to the paradigm where mass customization, each and every shoe of yours can be customized, and it actually is being customized by the, all these Adidas and Nike and all Reebok people. So what do we need to do under the scenario? We need to be disruptive and creative, and yet very simple. I hope you all remember that Three Idiots were a story of virus pen. So that's a real scenario that in 1960, when NASA was faced with a major problem, astronauts needed a pen that would write in the vacuum of space. NASA developed the astronaut pen for $15 million. But the Russians were also faced with the same dilemma. What they did, they used pencil for that. Yes, it's a different thing that pencils have their own implication, but at least that was something very simple to solve a problem immediately. Long term, you can do a lot of things. So I think we need that kind of an approach whenever we are looking at resolving any of our problems with leveraging technology or leveraging innovation. And then whenever we talk about all these technologies, all these different aspects of M2M to IoT, LT to 5G evolution, or whether we talk about big data, artificial intelligence, quantum computing evolution, and then if I look at these technologies in context of cities, smart cities, sustainable, secure, and resilient cities, there's a very interesting scenario that we look at. Hmm? The way our government of India, MAHUA, the Minister of Housing and Urban Affairs, defined the features of a smart city. These were different 24 features identified by the ministry, and if we try to map it to the ICT and IoT opportunities, we realize that they are in all these use cases, areas, domains, applications. ICT and IoT have a major opportunity, but what is happening? But if you really take a look at the smart city and smart infrastructure, a back of envelope calculation of this thing next 5 to 10 years, we are looking at 250 million smart electricity meters that are going to be procured and deployed under National Smart Grid Mission, beyond Smart Cities Mission. All these smart meters are going to use 250 million communication modules and 500,000 gateways or DCUs, as they call it. Then smart street lights are going to use another more than 100 or 200 million communication modules. Smart buildings are going to use another 50 million smart sensors and maybe a couple of hundred gateways. Automobiles shall be using another couple of hundred million communication nodes for the vehicle O&M, V2V, V2I, and other telematics applications. Similarly, when we start adding all these different applications, whether smart water, gas, traffic, environment, sewage disposal, we are going to use a few billions of smart sensors with communication modules. To summarize, India alone is going to need a minimum of 5, right up to 10 billion communication modules to be integrated into smart sensors and controllers, and 10 to 50 million gateways that shall be needed to operate and maintain the nationwide critical infrastructure that needs to be deployed to enable and empower the citizens to lead a sustainable, safe, and secure life. But these numbers are not visible. Why? Because this market is totally fragmented. If you look at it, because all applications live in silos. Each ecosystem uses different technologies, different protocols, different standards, different data models, and that's why the whole market being fragmented, we don't see these numbers, which are 5 to 10 billion communication module, is a much bigger number than the mobile market. Okay, and why we need to consolidate this? Because if we consolidate this ecosystem, this market, the prices of the communication modules, communication technology can come down drastically. So what is the problem? Common understanding is a big deal between different stakeholders. Okay, how to scope out the smart cities, or clear what are the universal values of a smart city? How do we reach consensus, on the core capabilities of smart city? And all these aspects need, very, very, you can say, comprehensive discussions among all the stakeholders, the SDOs, and all that. Otherwise, we will end up with a kind of scenario that you see in the picture, that two different people start from different end, and when it comes to meet, they're not aligned properly. So I think this is one of the very interesting problem that has been happening in all the ecosystems, not only smart cities. So that brings me to standards. And what are standards? Standards. So you see, these are some of the pictures of the early times of the standards. So standardization actually started way back in our, Mohenjo-daro civilization, Mohenjo-daro Harappa civilization. You see all these small pieces of chunks. These were the weights and measures standardized. And then on the right hand side, we even for the measurement, the length of the arm, this thing right from elbow to the hand, that was the measurement of the length, and then palm, and all these things started coming. And then among the, you can say, industrial stages, the first standardized thing was a screw cutting lathe machine, where we could cut the screws with a standardized pitch and standardized threads and all that. Okay, so these are some of the early standards, but I think we have a lot of now standards in each and every domain. But what are standards and what is standardization? Standardization is the process of implementing and developing technical standards based on the consensus of different parties that include firms, users, interest groups, standards organizations, and governments. Standardization can help maximize capability, compatibility, interoperability, safety, repeatability, or quality. It can also facilitate commoditization of formerly custom processes. In social science, including economics, the idea of standardization is close to the solution of a coordination problem, a situation in which hmm, all parties can realize mutual gains, but only by making mutually consistent decisions. Standardization is creating emotional balance, conventional detail, a universal familiarity, and natural definition of to a concept based on physical and emotional comfort and acceptance by changing societal behaviors and developments. So, what is the role of standards? Role of standard innovation and technology developments are accelerating. Strategic plans and roadmaps are needed to help ensure that the market is suitably served with the best practices that is pertinent to the goals and context of this very large market. Standards support our need to balance agility, openness, and security in the fast-moving environment. Standards provide us with a reliable platform from which we are able to innovate, differentiate, and scale up our technology development. They help us control essential security and integrate the right level of interoperability. Standards help ensure cybersecurity in ICT and IoT ecosystems. So the question most people would ask is, what do standards have to do with all this? So before I get into the answer, another conundrum on the standardization is that, as Andrew Tannenbaum said in 1990, the beauty of standard is that there are so many to choose from. In an ideal world, we would have exactly one standard for each task or interface. However, in reality, there are often overlapping or rivaling standards driven by different vendor camps. So what can a designer or developer do? Support all standards? Too expensive. Wait for one standard to replace all the others? May not happen. Implement a software abstraction layer that permits certain interfaces standards to be replaced? Good, but only if possible in certain cases. Choose one standard and accept incompatibility with all others? Bad, but sometimes that ends up being the only choice. So the irony of standards and even SDOs are that they are not at the forefront of the solution designers, developers, providers, deployers, or users' minds. There are misconceptions on what standards are for, and the case for use of standards has not been properly made to all the stakeholders. Most researchers, design engineers, and even startups argue that standards block innovation. In fact, standardization brings innovation and spreads knowledge. Standardization helps define the contours of structured innovation, first because it provides structured methods and reliable data that save time in the innovation process, and second, because it makes it easier to disseminate groundbreaking ideas and knowledge about leading-edge techniques and technologies. Liberalization and markets have a lot of great virtues, but they cannot create their own conditions of existence, and they must be designed, and that's where standards do help. If you take a look at the communication technology, you see how fragmented the standardization landscape is. There are so many bodies who are trying to do their own set of standards, some of them at times overlapping and conflicting. And this is just a very small few SDOs. I have not got a whole plethora of this thing. It's a non-exhaustive look. But what does it show? That we need a more harmonized. So what is happening? Rather than creating a symphony, it is creating cacophony of the standards. And reminds me of this very famous picture from the as enraged musician from William Hogarth in 1741. Everybody trying to beat one's own trumpet in its own way simultaneously without any harmonization, without any symphony. So what do we need? We need someone has to orchestrate the symphony of standard, because that's only it becomes valuable, it becomes useful to the stakeholders. And in fact, it is unlikely to be which standard, rather which standards, since most architectures do not pick one standard, but have a layered approach capable of using multiple standards in the portfolio. So the question that we have been asking in our global ecosystem of standardization is, will system standard be able to do it? And the answer has been yes. And we are working on a lot of system level standards, architectures, frameworks, and all those scenarios, which I'll be talking a little more later on. And the interesting part that if you see, The technological trends in smart homes, smart buildings, smart cities, and smart grid are being considered and pursued in isolation from each other by the respective stakeholders. If you look at today now closely, they form very tightly interwoven, homogeneous confluence of similar technologies being applied in different domains for a, again, common cause of making our planet Earth smart, green, and secure. But we all these ecosystems evolved in silos and they adopted, developed different siloed standards. Today we are converging. So I think we need a very more holistic, more comprehensive approach to have well aligned, harmonized, if possible, unified set of standards for multiple use cases. So communication standards imperatives. Multiple utilities are going to leverage and deploy similar technologies and solutions to improve their respective operational efficiency. But there is no common framework and architecture defined for the various physical infrastructures to be deployed in the proposed even smart cities to work in an integrated, harmonized, and optimized manner. Data sharing among multiple stakeholders in a smart city, for example, is a major challenge. You will say, why I'm talking time and again about smart city? Because in smart city, you see, you have multiple utilities, multiple citizen services being, offered concurrently in the same geographical territory. And today, what we have for each and every utility and each and every civic service provider, they set up their own individual ICT backbone infrastructure and all that, and using their own respective favorite standards. And that is what is creating the real problem. There are numerous use cases in every application domain of the smart infrastructure domain. So the problem that we are looking at is if the standardization, harmonization, and interoperability aspects of smart information communication infrastructure are not addressed immediately, then we shall end up having multiple smart devices which cannot talk to each other even if they are in the same room, simply because they belong to different smart solutions. In today's scenario, where all the siloed legacy ecosystems are converging into homogeneous, comprehensive, smart infrastructure ecosystem, this becomes the most critical imperative for the global SDOs. So one of the most challenging imperatives that we have identified for the SDOs is harmonization of standards in all these diverse, fragmented ecosystems for smart, sustainable, and secure communities. And another two underlying philosophy that we have already highlighted and underlined is, as I earlier mentioned, standards are the chromosome of the smart infrastructure. And another thing, everybody is talking about data is the oil of the 21st century without pollution side effects. But then big data is the crude oil because it needs a lot of processing before it becomes usable. And when we talk about the digital revolution, we are looking at all these technologies, IoT, 5G, 6G, big data, artificial intelligence, quantum computing, and whatnot. You can go on and on. So coming to IoT itself, so I think today we are at the stage where I would like to call it IoT 2.0 because IoT already has come of age. IoT, a concept that originally sounded like something out of a science fiction movie. The Internet of Things is in fact a reality and one that is bound to become even more widespread. From being considered as one of the most disruptive technologies in the early years of last decade to coming to on the verge of becoming one of the most profound technologies by weaving itself into the fabric of everyday life until it becomes indistinguishable from it. So if you want to define the IoT system, different people, they would try to define it in a very different way. Like, most of the, startups or, young people, the way they look at it, they think it's just one gateway, one box you got, which is connected to the internet, and you can connect your different devices, sensor through that box, and you are connected to the sense and IoT, this thing. The way our cellular service provider, telecom service provider would like us to believe what IoT is, that you put a SIM into this thing, cellular module into that any device connected to any sensor device, product system, and it becomes an IoT ecosystem because it's now connected to the internet. The way some other people look at it, like this, like building automation, smart cities, smart lighting, smart grid, smart health and industrial automation, multiple use cases of IoT ecosystem. So it is, but actually it is not about these things. It's all about services. Rolling out IoT is like rolling out largest control data network in the world. So I think this is the perspective that we need, this thing. And if you want to define, the way I would like to define it in a very simple manner, though there are multiple definitions that you can look at, but this is a very, my interpretation of IoT or Internet of Things is it is all about heterogeneous and aware devices interacting with each other to simplify people's life in some way or the other. So it basically boils down to this only. Uh, and technical perspective at a macro level, it could be split into three layers: sensing layer, communication layer, and management layer. But going a little one step deeper, you could split it into sensing nodes, local embedded processing nodes, which basically collect the data from sensors and to do the local processing. Then we have connectivity nodes. Then your software to automate the task and enable new classes of services, remote embedded processing node, and last but not the least, full security across the signal path. But so you'll say, what is different about IoT? So we have been doing this communication, remote monitoring, control for ages, and it was called machine to machine. Now, why are we calling it IoT? And what is the difference between machine to machine and IoT or any other simple control automation monitoring system and an IoT system solution? So it now takes at all the issues and aspects in a very holistic manner. So the IoT is all about device management, access management, compute management, protocol management, data management, and connectivity management. All these things are dealt in a very comprehensive, structured, standardized manner. And when you look at the plethora of the different technologies, you have from operational technologies to information technology, there are multiple stages, like from peripheral devices, edge gateways, field area gateway, enterprise gateway, storage system, data processing system, application, then workflows. And when so IoT can address any OT use case, which are basically event-based actions on real-time and high-velocity data, or even IT use cases like query-based action on non-real-time high-volume data. So IoT is all pervasive. It can take care of all your use cases, and IoT use cases are already ready for implementation, which we have been seeing over a period of time now. And I don't need to go to this particular point at least. It's a common knowledge. But how this is evolving? So I think it is basically about technologies in support of business evolution. As new technologies or communication technologies keep on evolving, new and new use cases, for business and opportunities, domains, they start becoming more viable, more easily controllable. And so if you see the evolution of these use cases, current on the road to 5G and 5G experience, so we have these, if you just look at few examples of enhanced mobile broadband, automotive, manufacturing, energy and utilities, and healthcare, So we have all these multi-standard networks, CAT, M1, NB-IoT, cloud optimized functions, virtual network function, orchestration, etc. So we have these screens everywhere, on-demand information, process automation, metering, smart grid, connected doctors and patients. The moment we start going to the further level on road to 5G, we are already enabling now 4K video, real-time information, vehicle-to-vehicle, flow management and remote supervision, resource management, automation, monitoring, and medication e-care. Going forward with the 5G fully in place, we'll have 4K, 8K immersive experience, very good leveraging the AR and VR, autonomous control, cloud robotics and remote machine intelligent and real-time control, remote operations, 3D CT scans, and all these kind of use cases will become available because these are all dependent on the evolution of the technologies. And IoT, as you know, it may require differentiated service levels. IoT, because it covers a large range of applications, it can be machine to machine or consumer or healthcare or automotive. These applications will have varying degrees of requirement for connectivity as well as data transmission. While a healthcare device may collect continuous amount of data, a smart appliance may not have to be transmitting continuously. We can even consider within an automobile, for an example, various systems. All the systems related to safety may need continuous monitoring and real-time feedback. However, an infotainment system may have a different requirement. Environmental applications such as clean air and water monitoring system may have another set of requirements. All these applications will transfer varying degrees of data, some large, some small, and others will be a mix of these and at various intervals and versus real time. It may be important to understand that these requirements from a systems perspective and offer differentiated class of service within a network that provides connectivity. So IoT is not about same technology being, same communication technology, protocol standard being applied everywhere. You will have to understand each use case, each application requirement, and then pick and choose the communication technologies, the protocol, the standards, and the module, the hardware devices, and all that to provide the differentiated service level and quality that is needed. Talking about application and business models, the reality check of the hypes, myths, and contemporary practices and imperatives in the socio-techno scenario of this thing shows that most analysts projected 20% CAGR for IoT. And that's a faster adoption rate than the growth of any economy. To some, that means the things are not broken. However, the ground reality in India and even beyond, even outside, is a far cry from this rosy picture. All IoT companies are still struggling to get a foothold on the market. Profit from IoT for different nations, different ecosystems, and different stakeholders is highly dependent on the macro dynamics in their respective environment. A comprehensive environment scan of the macro dynamics within one's own socio-economic environment can only help understand their impact on any IoT organization's business revenues and provide actionable insights to address the challenges and develop a long-term strategy and roadmap to evolve and mature into sustainable IoT organization. So what are the hurdles in the fast growth? I said the things are not as rosy. What are the problem is that it is difficult for innovation to happen across these jointed platforms and technologies. Right now, everybody is working in its own heterogeneous, fragmented manner. No company can do it all, but this can only happen when an open ecosystem contributes to the overall solution. Creating opportunity for ecosystem partners to work across common open platforms will facilitate faster innovation. Okay, so we need to, put a lot of structure into this, haphazard, disjointed platforms, technologies, and the way they are organized, the way they are leveraged by the stakeholders. The IoT value chain, if you look at, is perhaps the most diverse and complicated value chain of any industry or any consortium that exists in the world. Why? Because the gold rush to IoT is so pervasive that if you combine much of the value chain of most industry trade associations, standards bodies, the ecosystem partners of trade associations and standard bodies, then add in the different technology providers feeding those industries and ecosystem stakeholders, you get close to understanding the scope of the task. IoT is everywhere. It has become so pervasive that you don't know where to control it, where to define it, where to put a stop to it. So that is where it's such a complex, complicated, and and still heterogeneous market that understanding, bringing some kind of a harmonization in this heterogeneous scenario is very, very difficult. We need to see more acceleration and maturing of common standards, more cross-sector collaboration, and creative approaches to business models. Hence, in spite of much hype and even genuine potential, the IoT paradigm has not yet proliferated in a true sense to the desired potential. Bringing the Internet of Things to life requires a comprehensive system approach, inclusive of intelligent processing and sensing technologies and connectivity, software and services, along with a leading ecosystem of partners. To give IoT the required momentum, device management platforms, cloud computing, big data sciences in the virtual world are already flourishing and well geared up to meet the expectations of the designers. But the physical world needs to catch up. The wireless and networking technologies need to mature very fast. We need innovative approaches in deployment of large sensors and actuator networks. And the kind of competence to design and innovate that we need for IoT is very, very interesting. Every true IoT application or solution needs cross-domain expertise. Though internet per se has been considered the forte and playing field of software professionals, IoT brings new challenges in the ways of sensor fusion, communication technologies, energy and power management on the edge nodes. Unless a designer can design the most optimized edge nodes and communication nodes, the solutions shall not pass the acid test of reliable and sustained performance in the field deployment environment. However, it is high time we try to bring some semblance into this chaotic paradigm by bringing the system approach to resolve the complex problem. There is still ample scope to harmonize quite many aspects and bring interoperability among multiple competing and or conflicting standards, be it in syntactic or semantic aspects. or at different layers of protocol like network layer, application layer protocols. So just to give an example of different standards and layers, you see, this is the way you could even look at it. Like we have transport layer, communication protocol, then profile data management resources, and then application and services thing. So if you see, the most of the standardization is in this area, okay? And there are still a lot of gap areas where we need a lot of harmonization, okay? And if you look at it from a simple IoT layer model, from standardization protocol perspective, we have transport, communication, profile data, application services. And where do we, sorry. So these are the three layers across which standards will apply around this. So application services can be always customized. There's nothing wrong. But what you need to standardize and have unified standards is among the transport layer, communication protocols, profile, data resources, models, etc. So standard landscape, so many industry consortia and all that within IoT itself. There's so many, but so there are lot of, but lot of these things are more proprietary or closed ecosystem of industrial consortia, etc. Now, if you just to give us very simple IoT architecture and protocol, I don't want to get into detail this thing unless we have time and interest, though I can get into and then maybe one of the future discussions. So IoT architecture, you look at, you have some kind of a processor where you Linux OS, supervisor, different apps ported. They communicate through different, so OMA DM is the device management, for a standard, and MQTT or CoAP can be you can say application transport layer and all that. So you can through these, you connect to the cloud server, then you have the low power application ad hoc, then your radio module, then your network operator, which also takes care of the, device management and all that, plus offering you all the services. So what is the challenge? The dilemma or the challenge about the convergence is that device management is not an option. Every processor, every application needs to be configured, upgraded, and monitored. People are doing it in a proprietary siloed way. I think there are already global open standard, which I think you should look at and start to adopt them. Each protocol must be secured and synchronized. You can't trigger an update with a protocol while you are already rebooting the device using another. So you need to be very, very structured and synchronized among different, tasks within the solution system product that you're running. M2M IoT is not a simple problem. Security and provisioning are really the hardest ones. Try hard to reduce the number of protocols to make your life easier. There's no single protocol to rule them all. Every protocol is nice and specialized, but that's where the challenge or the problem for the designers or design engineers come in. So another few challenges in the fast growth of IoT. The challenges that inhibit the IoT related standards and hence a robust rollout of IoT services are security and privacy issues. Note that security and privacy measures are at a lot of times at odds with each other. Endless IoT application. How do you standardize across different applications? So many of them. Endless potential types of edge node technologies and the interface to the communication nodes, for example, sensors and use case integration into telco services. High fragmentation of today's IoT connectivity solutions. Lots of legacy systems that will now be part of the IPv6 networks with no or minimum existing coexistence and interoperability plans. Partnership between heterogeneous and diverse industries and defining the associated business models involving multiple stakeholders and service providers of some of those legacy systems in numbers. Management and provisioning of various network devices, applications and services, and the network capacity planning that comes with it. Regulatory issues that will hinder deployment on a worldwide basis. Special needs of industrial grade product rollouts and with long-lasting requirements in the field that require future proofing of any standard recommended. Slow development of the IoT services market, partially due to lack of future-proof standards. So, because when we are looking at these things, I think another thing which is important is to look at what are the core characteristics of an open infrastructure, because that's what we are looking at this thing, and we are trying to understand the role of standards and open-based architecture. And any open infrastructure and that's most valid for IoT use cases and applications. Shareability, ubiquity, integrity, ease of use, cost effectiveness, standards, openness, secure and scalable. And interoperability imperatives, if we look at, So I think we need a comprehensive interoperability between system A and system B. And so if you want to look at it at the layers, so they are function, basic connectivity, network interoperability, syntactic interoperability, semantic understanding, business context, business procedures, business objectives, economic and regulatory policies. But if you want to summarize them, they can be summarized into these 5 layers, which are on the right-hand side: business layer, function layer, information layer, communication layer, and component layer. So you need interoperability across these 5 layers or any sub layers out of these to make sure that your product system solutions from one system to another are comprehensively interoperable. They can seamlessly share data and information with each other. So another thing which I've been just mentioned also, the smart but not secure, because we know the chain is only as strong as its weakest link. Currently, the weakest link in the smart infrastructure or IoT signal chain is our smart nodes itself and nodes itself. A robust communication IT infrastructure shall be no good if we continue to use devices which are not equally secure. So the new imperative for design community is to design smart and secure phones, sensors, devices, or instruments. Then to sum up the IoT paradigm and challenges, what IoT is all about? It's a global neural network of networks, homogeneous network of heterogeneous devices, industrial IoT versus consumer IoT, IoT app services versus IoT applications, and different domains, infrastructure, enterprise, homes, IoT is everywhere. And the challenge I once again to highlight, end-to-end security in the signal chain. So now what I'm going to do is I'm going to give you a flavor of very interesting standardization approach that we have followed in India. So this is what will actually give you, put the whole discussion that we had, rather what all I talked, in the right context and how we can achieve, how standards can help and what kind of approach or thought process we need in the standardization. Okay, so as I already mentioned, current applications live in silos. So what we did was we were looking at this problem, and what we saw that if we want, like as I gave you an example of smart cities, all these 10, 15 different utilities and civic service providers, they all set up their own ICT backbone. So what we did was we tried to look at the common layers between them and try to standardize, come up with a unified architecture and a unified one common ICT backbone for the smart city. But upper layers, so here, if you see, this is the our, you can say, unified abstracted architecture for this thing. I'll not go into detail into much because but that I'll be happy to do that if we have time. But what we'll stick to right now is communication aspect. So when we look at zoom into the communication layer, how we can standardize it and unify it. So this is what I'm going to talk about in next few slides before we close. So last mile communication. So what we see is, as we already saw, different devices, different sensor, different application solutions use different communication technologies, protocols, and even data models. So end sensor connectivity is very heterogeneous and a good candidate for evaluating the needs for a unified communication stack. So our initial focus was constrained RF networks for control and monitoring non-streaming in sub-gigahertz band. Unlicensed band, spectrum. So what we realized was it is an unlicensed band. Spectrum is conducive to higher penetration. Few million energy meter street lights are already deployed. We do not have no complete stack over IEEE 802.15.4. Possibility of increase in unlicensed spectrum to accommodate denser employment. I think WPC has already released 1 megahertz more, and they are going to increase much more, 6 megahertz in very near future, and then maybe 20 megahertz further in very near future, totally delicensed. Okay, so it's a very very interesting you can say case to study, analyze, and come up with some kind of unified stack. So what we realized was that the key characteristics of last mile communication technologies and their respective communication protocols defined as one of the principal constituent of the unified ICT architecture for smart infrastructure is the need to connect heterogeneous devices with the heterogeneous applications while maintaining the necessary interoperability across all such devices. Irrespective of the diversity in the PHY and link layer technologies, offer a seamless view to the application. They should also allow connectivity to existing infrastructures and to internet. In this regard, a comprehensive review of the suitable candidate technologies Protocols and standards for unification of the last mile communication for smart infrastructure needs is a prerequisite, and we did some holistic study. Okay. And the approach that we developed was that we need to define an interworking layer to allow interoperation of existing systems and the higher layers, IP and above. Going forward, standardize a small set of optimized profiles by proposing the specific protocols and higher layer functions. Focus on security and interoperability of the solution components, and define conformance test along with the standards. Because developing a standard is one thing, but we need to have a conformance testing framework schema also, because we need to test that the way people have implemented the standard. Does it actually bring the interoperability between the two different set of devices? So you know this famous OSI reference model about 7-layer physical data link, then network, transport, session, presentation, and application. We looked at that, and our approach was through a common network layer protocol. IP-based last mile architecture will enable interoperability at multiple levels. Among heterogeneous link layer technologies such as IEEE 802.11, IEEE 802.15.4, cellular, Bluetooth, power line communication, PLC, etc., and among heterogeneous requirement in applications such as web-based configuration system, publish subscribe protocol, etc. We looked at all these things, and the 6LoWPAN, the IPv6 low power, personal area network adaptation layer defined by IETF integrates the IP-based infrastructure and heterogeneous last mile field devices by specifying how IPv6 packets are to be routed in constrained networks, such as the IEEE 802.15.4 network. Hence, 6LoWPAN is considered as a universal adaptation layer for IP enablement in the last mile communication protocol stack. This thing. It is also essential to unify the networking and data transfer stack for higher layers, ranging from network layer to the application layer, to make it easier for various protocols and stacks to cross-function, irrespective of the underlying PHY and MAC layer technologies. The unification of last mile communication can be achieved by standardizing layer 1 and 2, PHY and MAC network, which we are calling it network access layer, standardizing layer 3 and 4, network and transport layer, which are mostly standardized for the IP use cases. Okay. Standardizing layer 5 to 7 application. This is another very, very challenging, complex problem because this is where the heterogeneity becomes all the more fragmented. Okay, not only diverse, but fragmented also. So introducing a new layer, network access interface layer between layer 1 and 2 and layer 3 and 7. So what was our approach? To achieve seamless interworking between different communication technologies, respective PHY and MAC layers, respective characteristics and data frame structures, and the standardized layer layer 3 and 4 stack, it shall be required to customize the interface between these two macro layers with each of the different communication technologies being used as per the need of the deployment consideration. The network access interface layer introduction shall ensure that neither the standardized layer 3-4 stack, namely the network transport layer, nor the layer 1 and 2, namely the network access layer of any communication technology stack shall need any changes. This network access interface layer shall provision and address all the interworking requirements. Okay, and then standardizing layer 5 to 7, which is basically the essence of the application layer, to achieve end-to-end unified stack and to achieve interoperability in truly comprehensive manner. It is important to have interoperability at the application layer as well. For this, we need to standardize the payload and data semantics as well. This is one of the most crucial aspects to be addressed in the smart infrastructure domain. It has been observed that it is feasible to standardize the comprehensive set of data semantics for the smart infrastructure. However, creating and standardizing a very large list of growing larger with every time of data semantics shall not serve the purpose of such a complex and heterogeneous domain. We need to either identify any existing or create framework to define a huge and ever-growing number of data semantics in unified, harmonized, and structured manner. Rather than creating a list, we need to have a framework where anybody can define new data semantic made up models for any new use case in a seamless standardized manner. So that is what we also looked at. So what we are trying to do is that the comprehensive set of standards thus developed shall ensure that objective to create a unified and secure stack architecture where unified upper layers shall harmonize and interwork with different technologies at lower layers in a homogeneous manner. Okay, and it is efficiently and seamlessly achieved. This shall enable addressing multiple heterogeneous applications, use cases, and deployment scenarios using diverse technologies in the same geographical territory in ubiquitous and comprehensive, yet most optimized and sustainable manner. So how do we do this? So this is the stack reference architecture. I think you might heard a lot of text and read a lot of text, but so let me explain it here. So at the bottom, you see network access layer. Basically, this is Phi and MAC, L1, L2 of the OSI model. So here we can have multiple, any technologies. Now, about this, as I mentioned, we have a network access interface layer, which is the new one which we have introduced. Okay. Now, what it does, it makes it irrespective of whatever Phi and MAC, it makes it seamlessly interwork without changing your transport and network layer. Okay, it brings the network access interface layer with a standardized stack of your network and transport layer. And then on top of it, so these are already in the transport and network layer are already standardized. If you buy any cellular, or Wi-Fi module, you get layer 1 to layer 4 already loaded on it. What you do need to do is the application layer. And this is where the maximum heterogeneity and fragmentation is all about. So our focus was to now how do we standardize this also. So you see security is across the layers, which is standardized. Okay. So with this is the overall, just a very quick, I can go into deep dive later on in some detailed session if needed, but this is what is the basic, you can say stack reference architecture. So as I told you, the UDI, we call it UDI means Unified Digital Infrastructure. LMCPS is the, you can say last mile communication protocol stack. Application layer consists of a tightly coupled set of definitions, functions, and characteristics. Now I'm going to give you a peep into how we look at the application layer itself, where the maximum heterogeneity and complexity lies. The application layer comprises of communication protocols and interface methods used in process-to-process communication across an internet protocol network. Application layer only standardizes the payload frames and interworking between different end nodes and application level. The communication depends upon underlying transport layer protocols to establish host-to-host data transfer channels and manage the data exchange in a client-server or peer-to-peer networking model. Though the TCP/IP application layer does not describe specific rules or data format that applications must consider when communicating, the original specification in RFC, IETF RFC 1123 does rely on and recommend the robustness principle for application design. The security block or layer consists of tightly coupled set of definitions, functions, and characteristics for comprehensive and intrinsic security in the unified protocol stack architecture. It comprises of set of security standards to be used to address the security requirements of the stack comprehensively. The chosen standards may be used at different layers of the stack depending on their context. This block may need to be defined differently based on the technology being used at MAC and Phi layer. However, some different communication technologies may use a security block common to some other communication technologies as well. So getting in a little deeper into, I'll not go into detail, but I'll just quickly run through it because we are, I think, short of time. Okay, but I'll just give you a good sense of what are the application layer requirements and how do we analyze them. So the scope of application layer is very interesting. The application layer definition is purely applicable for devices operating in the last mile constrained networks of the nation's smart infrastructure. Devices in scope, constrained and ultra constrained devices, devices that may have sensors that sense, measure some metric and or control applications, devices that have IPv6 connectivity, non-IPv6 devices are not in the scope for this particular stack architecture. Operating in scope, managing, controlling of such devices, changing parameters on device, remotely updating firmware on those devices, and identifying ownership. So key application characteristics, payload carriage, device management, communication protocol modules, reliability and security, and transportation. Okay, so they are complete detail. I'll share this slide deck. You can go through it later on and come back to me in case you have any. Okay, so what we did was we first of all even did a holistic study and evaluated these things for against a lot of these characteristics like efficient transport, distribution overhead, reliability, security, restfulness, near real-time support, blob transfer, payload agnosticity, multiple transport profiles, and support for common communication models. So we did all this study for different use cases. And then device interoperability for IoT system. Some of the option for integration of legacy systems and solution and backward compatibility also we looked at. integration at the backend system, integration at the gateway level, or we bring in the common device protocol. Common application layer and device data semantic need to be defined. Currently, there is no universal protocol and domain-specific protocols are prevalent. Option 1 and 2 can be used for non-IP based communication, okay, or domain where normative standards are already defined and in practice. So option 1 and 2 are just at the integration at the higher level, not at the for the new stack that we are talking about. So this is now if we get into further blowing out the application layer into this thing. So these are the different aspects within the application. Further zoom in into the application layer, and now requirement of device application layer. It has to be network agnostic. It has to be suitable for all kind of device types, security, reliability, device management, device operation, and data semantics. So then we looked at all these aspects. I'm not going to that. How do we go further zoom in into the network agnosticity? How do we look at the device types? How do we look at the security? How do we look at reliability? Then device management itself is a very important part, which I mentioned. We need to have standardized device management approach. So within that, these are the kind of things that we need to look at: the identity of the device, firmware, security, configuration, monitoring, alarms, and events. Then this is further detailing on the device management. Okay, for lack of time, I'm not getting into it. So these are the kind of device provisioning aspects. Then we have the configuration, we have monitoring and diagnosis, we have device maintenance, device operation. Okay, and then also we need security policy requirement driven from the policy. Then there's another important part which I mentioned about unified framework for data semantics. You'll say what it is all about. Okay, so I think I'll not go into much detail, but the point is whatever values, like you see, if you talk about any particular parameter like energy monitoring, whether it is coming from a utility smart electricity meter, or it is coming from a street light, whether it is coming from any other machine equipment, motor, whatever, pump, the way we call different parameters, there's the data model, the data semantics should be same. That was our basic thought process. And we have identified a very interesting framework where we are basically that is capable of supporting multiple kind of data. It supports different parameter value, uniform extendable parameter coding mechanism, registry or global database to looked already assigned parameter codes. So what kind of this thing? So these are some further you can say deep dive into data semantic aspects. What do we need? What it should have? The kind of the framework that we need to choose. Okay. All these are the expectation of the stakeholders. Based on that, we develop the requirement, and then we choose or design the framework for the data semantics. Okay. So just to give you a summary of this application layer stack architecture. So I think this is the one. Yeah. Yeah, so I think so if, this is the way you can actually split the application layer into this. So we have this on top, we have the use case device application, then data model structures, interaction model, action framing, encryption, decryption, message framing and routing, IP framing and transport management. So here is what we have already selected for our Indian stack. DLMS objects in LWM resources is a data model structure. Interaction model is scope, CoAP, and get input. Action framing, CoAP, action framing numbers. For example, what the examples are there in CoAP. You can study from IETF RFC. Encryption and decryption, TLS and DTLS, based on whether it is TCP or UDP. Message framing and routing, TCP, UDP, and IP protocol. IP framing and transport management, cellular, Wi-Fi, Wi-SUN, etc. Any of these can be there, which can be handled, which can be seamlessly, where they can work with our application layer stack architecture that we have done. So I think I'll like to conclude on this thing. So what do we need? We need to, the premise of a smart city has evolved from technology-centric project to one that leverages technology to create a sustainable and citizen-centric environment. It is no longer enough simply to deploy sensors. Companies and government need to demonstrate a meaningful impact on the population. Keeping pace with the challenges presented by COVID-19, escalating sustainability commitments and ongoing population growth will require unprecedented urban investment and innovation. We see smart infrastructure as pivotal to smart city, and these IoT standards and IoT solutions are going to be further more useful. As I showed you, in all the use cases of 24 different features of smart cities, everywhere IoT and ICT can play a role. So what was we learned? That it was evident that there is a glass wall barrier between communication protocols and standards for IoT applications and that for infrastructure and industrial domains, popularly called OT applications. In spite of evident appreciation of strengths and weaknesses of both classes of standards, there has been no initiative by any global SDO or industry consortia. And that's why we in India try to focus on this. So this exercise that I just gave you a very quick brief summary of is an effort in this direction with intent to break the glass wall barrier and homogenize these two siloed paradigms comprehensively by developing a unified last mile communication protocol stack architecture, leveraging the best of both the worlds and developing a communication technology agnostic, robust stack architecture that shall enable ubiquitous data sharing, seamless across domains, use cases, and applications. So this was all about this. So once again, just showing you the same a picture. So the way forward is the smart metering. So in India, I think we have the smart metering is already in advanced stage of deployment. So there shall be the first major ecosystem to leverage these standards and deploy the future AMI advanced metering infrastructure based on these standards, paving way for other critical civic infrastructure ecosystems and their respective stakeholders to follow suit in the converged unified digital infrastructure of the nation. In fact, digital infrastructure late deployed by AMI, advanced metering infrastructure, could be offered to other stakeholders to bring down their OPEX and generating revenue stream for the AMI infrastructure deploying organization. So this is another thought process that utilities are having to overcome this. So last slide, key takeaways. We humans need to radically change our relationship, not just with the planet, but with the objects with which we fill our lives. We need to change how we think about technology and innovation. Rather than allowing technological advancements to steer our narratives, innovation and technology should help us build bridges between the worlds we inhabit now and the ones which we imagine for tomorrow. With that, I'll stop. Thank you very much. Any questions? I think I still overshot my time.
Yeah, dear participants, if any queries, you can let us know in the chat section. You can post it in the chat or Q&A, or else you can also raise your hand so that we can unmute you from the host end and you can interact with the expert. Thank you.
No questions? Either no one understood anything or maybe it was too clear, which I doubt.
So there are some comments from the attendees. So one participant, Padmavati ma'am, says that thank you, Kishore sir, for the excellent and wonderful session. So she has messaged me, messaged the host privately. Another participant says Siba S. She says that it was clear. It was clear your concepts. It cleared our concepts. So that is what she messaged. So dear participants, if you have any questions, let us know.
And
there is one question. Yeah, so there is one question from one participant, Lavanya T. So she is asking, sir, which layer of IoT is most vulnerable to security issues?
So I think as I mentioned, the chain is as strong as the weakest link. So when you talk about security, your each and every layer has to be secure and strong in itself without expecting if my upper layer is secure, my lower layer is secure, so I can be unsecure. No, but all the same, as I mentioned that L1, L2, L3, L4 are most of them are standardized, so they are already secure. When you get a module, most of the security are taken care. what you as a design engineer, as an innovator, as a startup, as a soft developer, what you do is you work on the application layer. So this is where you need to focus, that your application layer, your data model, your all the payload, everything is properly secured. So that is where you as design engineers need to really focus on. The other stacks are layers are already standardized by the respective standardization body, whether IEEE or IEC or ISO or ITU. So I think this is application layer is one which you develop yourself or you customize yourself based on your use cases. That's where you need to keep your focus more. I hope that answered the question.
Okay. Yes, sir. Thank you, sir. Thank you for solving the queries. So one comment from a participant is, it was clear and good technical explanation, sir. This is a comment from the participant. Yeah. So thank you. So dear participants, if you have in case any other queries, let us know in the chat section in the Q&A. We will wait for a minute and then we will go towards the next session.
So I think there's a question, I think, from Devishri Naidu. Is that the same one? Can you explore the scope of work related to device security as per your framework, network layer, interface layer? Network layer interface. Okay. So I think this is again when we create this interworking layer between the L1, L2, and L3 to L7 stack, there again, whatever mechanism, the glue logic that we develop, that has to be secure only, and that is part of the stack development. So I think if we go into deep diving into the detail how that layer is being developed, then I can give you more clarity on how the security aspect has been taken care into. But otherwise, it will be very difficult to explain you how it works in the on that layer, how we have ensured the security aspects on that layer. But suffice to say that, so what I'm going to do, as I mentioned, I'll share this slide deck with the Academy the people. They will forward it to you guys. They'll share it with you. And you have any queries, you can get back to me one-to-one or however, through mail, through chat, through whatever. And I'll be more than happy to, provide you further clarification. In 1 hour, I couldn't provide you more detail than this. I'm sorry.
Yes, absolutely true, sir. So, dear participants, the slides will be shared with you. So, in case of any queries while reading the slides, you can mail to sir and ask your queries. So, with this, we come to an end to this first lecture of today's program. So, on behalf of the principal coordinator of this program, Professor Ratnajit Bhattacharya sir from IIT Guwahati, and Dr. Bharat Gupta sir from NIT Patna, I thank you, sir, for accepting our invitation and coming on board and sharing your knowledge with
No,
all
thank you.
our
No,
participants.
it's my pleasure always. Thank you very much for the opportunity. Thank you.
Thank you, sir. Thank you so much. So, dear participants, now we will start with the next lecture. Dr. Mayank Agarwal, sir, are you there? Hello.
Hello.
Yeah.
You can hear me now?
So, yeah, we can hear you, sir. So we have made you the presenter in the meeting. So we request you to please share your presentation.
Tick. Optimized for image, optimized share screen. Okay. Just a minute. Share content, optimized for image, tap to see instruction. कुछ एक इशू आ रहा है स्क्रीन शेयरिंग में
So what's the issue?
पता नहीं वेबएक्स ही इशू दे रहा है जस्ट अ मिनट मैं एक बार वापस चेक कर लेता हूँ वेबएक्स एग्जिट हो रहा है स्क्रीन शेयरिंग के टाइम
Okay.
जस्ट अ मिनट ये है screen share, share content, optimize settings, allow. Is it visible now or no?
No, sir, it's not visible to us.
Share content optimized for video. Okay, allow. Start now. It's visible now?
Yes, sir, your mobile screen is visible.
ओके मोबाइल स्पीकर एंड फोन तो मुझे मोबाइल का फ्रंट स्क्रीन दिख रहा है या बैक
सर आपका मोबाइल का फ्रंट स्क्रीन दिख रहा है
फ्रंट
मतलब
स्क्रीन
स्क्रीन
दिख
दिख रहा है
रहा है
एप्लीकेशन नहीं
स्क्रीन दिख रहा है somehow webex में ना ये ऑप्शन नहीं दिखा रहा है स्टॉप शेयरिंग ठीक है I don't know why okay हाँ वीडियो allow start my video and let me just reverse the image now it will be visible okay people can see the screen here right
yeah sir but it is like you need to flip the screen sir it is yeah
नहीं मेरे को यही दिखाना है जो मैं दिखाना चाह रहा हूँ just a minute see it's a hands-on session so my audio is visible
so your audio is audible sir
हाँ audio sorry audio is audible and screen अभी दिखना चाहिए right okay now you can see ls and commands.txt right
yes sir but it is appearing vertically we request you to please flip your
अच्छा
smartphone camera so that we can see the screen horizontally
is it okay now कि अभी भी वैसे ही दिखा रहा है क्योंकि मुझे वो प्रॉपरली दिखा रहा है इंक्लिनेशन में
okay sir now it's okay
now it's okay right
yeah so shall we start like
yeah we can start
okay so dear participants welcome you all in this second lecture so our this lecture will be taken by our next expert Dr. Mayank Agarwal sir so before we start we will have a short introduction of our next expert so Mayank Agarwal sir did his BE in Information Technology from Sardar Patel Institute of Technology Mumbai. He completed his PhD in Computer Science and Engineering from Indian Institute of Technology Guwahati. His specialization includes 802.11 Wi-Fi network security, computer networks, frame capture and analysis, packet injection, track analysis. He did his postdoctoral research at Ben Gurion University, Israel, where he worked on malware analysis. He joined the Department of Computer Science and Engineering, IIT Patna, as assistant professor in July 2018. Dr. Mayank is also the professor in charge automation at IIT Patna and has been automating various tasks at IIT Patna. So with this short introduction, I welcome you, sir, on this platform to deliver lecture number 17, that is hacking in wireless IoT networks. Over to you.
Yeah, thank you for the kind introduction. So guys, since we have 1 hour, we directly start into the hacking session. So this will be a complete hands-on session and sorry for this delay because somehow the WebEx is not working on my back box system, right? Basically, you must have heard about Kali Linux. So Kali is a penetrating operating system that can be used for various hacking and those purposes. Fine. So somehow WebEx has issues and we are still not able to resolve it. So what I have done is like I have shared my screen and I have opened my terminal and I'm sharing through my cell phone's back camera, right? So hopefully the font size is visible, right? So you can see the ls is commands.txt. So I will just start with the very basics first. This command I think everybody knows. When you type ifconfig, you basically get the list of interfaces. Now, since it is basically the Wi-Fi interface, we basically see that this is WLPS30. This is the Wi-Fi interface that which my laptop currently has. Oh, right. So this Wi-Fi interface basically is telling that. So usually when you have a wireless interface, it will start with WL, right? In the older laptop, Ubuntu used to identify Ethernet as ETH0 and wireless with some other names. But this time we are getting this as a wireless interface. Now, what happens in a wireless interface is like, so whenever you want to hack into any network, first you need to listen to the traffic that is being generated. Then how do you listen the traffic? Now, if you remember the difference between a switch and a hub, right? So what a hub used to do, hub used to broadcast a packet to all the ports, and only the ports, only the machine with the destination MAC used to capture the packet, and others were expected to. The screen is visible, right? I think.
Yes, it is visible.
Yeah. So other clients were expected to behave in an honest manner, that is to drop the packet, but there was no guarantee. So in Wi-Fi, what happens is like, again, see, in Wi-Fi, the communication medium is the air, right? So by default, everybody who is within the vicinity can hear. It's just like a classroom, right? When the faculty is saying, all those in the classroom can always listen to what they are saying. Whether the students pay attention or not is their prerogative, but the information comes to every other user. So in Wi-Fi, what they made that, okay, the communication can be listened by everybody by default, but for that you need to set your Wi-Fi into a listening mode, right? Technically, this term is also known as a promiscuous mode, right? We will just see how that happens. Since we have a very short session, I will just quickly go through the commands, right? So the utility here is known as airmon ng, right? So airmon ng is a part of air crack ng, right? Air crack, basically it's a suite of Wi-Fi hacking package, right? Air crack is a very big suite developed by a single developer, and out of that, basically, now just let me type airmon ng and press enter, right? So now what it says is like, see, it says my interface, my Wi-Fi interface name is WLP3S0, right? And this is my Wi-Fi driver. Basically, it's the Intel WL is wireless and Wi-Fi driver, and basically it says what the chipset is, right? Now what happens is like, the command is airmon ng, and the command goes like this: start, and I need to type my interface name, that is wireless P3S0, right? And now I will press enter, right? So now let us see what things have come on the screen. It says found 4 process that would cause trouble. Now just ignore all these things. What is the main thing that I will tell you? See, now it says MAC 802.11. Basically, IEEE defines the standard 802.11 for wireless networks, right? The standard name is 802.11. So it says, see, monitor mode enabled for WLP3S0. Now, when it says monitor mode enabled, so monitoring mode, basically what happens is like, you can hear the conversation of other Wi-Fi clients in your nearby network. You can hear the conversation of other Wi-Fi clients in the nearby network. So then you may say, ki, okay, then is it possible to hack the passwords and everything, or whatever the people are saying? No, right? Because all the websites by default are SSL encrypted. So you will see all the encrypted text and not the plain text. Fine. So this is why we enable monitoring mode, so that we can listen to the traffic which is ongoing in the network, right? Now, when you listen to the ongoing traffic in the network, right? So now how do you do that, right? So for again, so now let us do an if config again. And now if you see in the if config, do you remember last time we had entered WLP3S0 only? Now you can see this interface has an additional 3 characters towards the end, which is known as mon, right? Now what does mon do? Basically, mon says that now the interface is in a monitoring mode. Now what do you mean by monitoring mode? So this interface now can only listen to the packets which are coming, right? Now I cannot access internet through this Wi-Fi connection. It can only passively listen, right? Always remember, any Wi-Fi device usually, when it sends a packet, it only is able to send the packet. It is not able to send and receive at the same time. right? Or else it will cause a collision, right? You must have studied the RTS and CTS mechanism, right? Request to send and clear to send, just to avoid the collisions and all, right? Now, since it is in monitoring mode, we can hear the packets that are traveling into the air. Now, how do you do that, right? So let me just type the command aero dump ng, right? And what was the name of the interface? Wireless T3 S0 and mon, right? Aero dump ng again is a part of aircrack ng suite, right? Aircrack ng suite basically is a complete Wi-Fi hacking and penetration testing, right? Penetration testing means if you want to just test how secure my Wi-Fi network is, you can use the aircrack ng tool, right? The moment I press enter, you will see a lot of stuff on the screen, but don't get scared, right? I will just explain what are each of the components in it, right? See, hacking does not mean that you write some set of commands and get the password. It is always required that to understand, okay, what is happening in the background, right? So now let me just press enter and you can see a lot of stuff appears on the screen, right? So this will take some time to explain, but let us see them one by one, right? So now what happens here, you can see this is a channel. CH basically stands for a channel, right? And in Wi-Fi networks, like, see, we have TV channels, right? We have the sports channels, cartoon channels, we have Discovery, Nat Geo, etc. These are all channels. So when you switch on your TV, you are exactly on a single channel, right? You cannot watch two channels on the same TV, right? There is no split view, right? You can see channel number 1 on the left side, channel number 2 on the right side. You can see exactly one channel at a particular time. Similarly, in order to have smoother communication, what does the Wi-Fi network do? It divides the entire spectrum, right? You must have had 4G spectrum, 5G spectrum, all these, right? So right now we are on Wi-Fi, there are two supported spectrum. One is the 2.4 gigahertz, which is well known as a Wi-Fi band, right? As a free ISM band, right? Industrial, scientific, and medicine, right? It's basically you do not require license for operating on this band. So all your Bluetooth, cordless, everything works on the 2.4 gigahertz band. In addition, Wi-Fi also has a 5 gigahertz band. Now you must have seen that dual Wi-Fi routers also come these days, right? Now let us see what happens on these channels, right? So basically what happens, you can see this dancings, right? 1, 7, 13, 8, 14 and all these things. So basically Wi-Fi defines set of 14 channels, right? Normally we use up to channel 13, right? Japan has a country which uses a channel number 14 also. So what happens here, see, there are different access points, right? The Wi-Fi routers that we have at home. So they can be configured anything from channel number 1 to channel number 14, right? So let's say some routers are on channel number 1, some are on 5, some are on 10, some are on 8, some are on 14. So what this utility does, basically it goes on every channel, collects some packets, then goes on another channel, collects some packets. Basically it does like a hopping. It stays sometime on channel number 1, packet captures, then goes on channel number 2, does the capturing again, goes on channel number 3, does the capturing again, and this is how it keeps on moving, right? That is why you see that the channel number are changing continuously. Elapsed is nothing but how much time this utility was running, right? So just like a timer. This is just the timestamp that is happening, right? And now let us see what is the BSS ID, right? So BSS ID basically stands for Basic Service Set Identifier, right? Basic Service Set Identifier. That is nothing but the MAC address, right? See, Wi-Fi basically operates at layer 2. At layer 2, you have only the MAC address with you. So every Wi-Fi router, so let's say your institution has 100 Wi-Fi networks deployed. So those 100 Wi-Fi access points will have 100 MAC addresses along with it. Fine. Then we have the power quotient, right? So power basically is measured in terms of dB and is in basically a negative sign. So what do you mean by a negative sign? So negative sign, as we know, as it is closer to 0, it is a larger number, right? So -5 is a bigger number than -40, right? So you can say this utility by default arranges access point in terms of their power. So for example, this FDP, right? So I configured a router for today's FDP. So you can see this is nearest to my laptop actually. So it is showing power as -17, showing that it has the strongest signal to my laptop. Next is the Wi-Fi with the name Maya, which is my home Wi-Fi router, right? The power is -31. So it is the second highest, strongest signal that I am obtaining. Fine. I'm just pressing Control C so that the process stops, right? And then we come across what are known as beacon frames. This I will ignore, right, for now, because what happens, there are some Wi-Fi router which appear occasionally or maybe switched off, right? So just ignore this with -1, -1, 1 and everything. So basically we see no data exchange here, right? So now what are beacon frames, right? So beacon frames basically are known as advertising frames, right? So now what do you mean by advertising? The simple application. See, for example, when you turn on your Wi-Fi of your cell phone or your laptop, you get a list of nearby Wi-Fi access points. Fine. You get a nearby list of Wi-Fi access points. Now, how does that list populate? Right. So, for example, when you go on the airport, you get a list of. Okay. So when you access the Wi-Fi access point, or for example, when you go on the airport, you get a list of Wi-Fi access points on the airport. Right now, how does that list populate? Right. Some magic does not happen. It has to go through something. Right. There is not a single guy on the airport that comes to you. Okay, sir, this is a list of Wi-Fi. You please install this on your mobile. Nothing of that sort happens. So how does your cell phone or your laptop come to know about the access points which are in the vicinity? Now that comes through basically beacon frames. Now what are beacon frames? Let us start Wireshark and I will just show you practically what are the beacon frames. So Wireshark, I think everybody knows, it's a packet capturing utility and you can get all the network interface, right? So I'm starting for WLP S30 mon, right? So you can see there are a huge amount of packets that are being sent in the network. Let me stop the packet capture because there are a huge number of packets here. The acknowledgement packets you can see. I will actually tell you why only this. For example, let us just check a beacon frame and I will then explain you how can we configure for more beacon frames. So this is a sample beacon frame, right? So this is a sample beacon frame. Let me just do one thing. Okay. Okay. Fine. Let me just filter this out. So filtering means now I hope it is visible. So you can see this in Wireshark. Basically, we have a packet number. Okay, just ignore. We have a timestamp. We have a source and a destination here, right? So basically, source. So whenever what happens, whenever we have an access point in the network, it basically keeps on sending beacon frames. Now, what does it mean by sending beacon frame? It basically advertises saying, okay, I am a Wi-Fi network in this, please connect to me. I have a Wi-Fi network, please connect to me. I have a Wi-Fi network, please connect to me. These are my details. So what happens is this net core, and we have a MAC address here 61710E. So let me just scroll this up. So when I do this, see, for example, transmitter address, right? You can see this transmitter address is 007263617110E. Let us search this in our terminal in which we were capturing this, right? So basically you can see this is the same Wi-Fi that we are seeing in the Wireshark 007263. Let us compare bit by bit, right? So we have 007263 61710E, right? Let me just start Wireshark 61710E, right? So now you can see this is the BSS ID. See BSS ID in Wireshark, you can see this is the BSS ID. So BSS ID is 007260, which is same as a transmitter address, right? Because in this case, the transmitter is basically the Wi-Fi router that is sending these beacon frames. So what happens when the Wi-Fi router sends these beacon frames? You can just see in the wireless management. You can see the SSID parameter is Anup Gupta, right? SSID is Anup Gupta. And now I will just show you in Wireshark. You can see this SSID parameter is set to Anup Gupta. So what happens here basically is that I am seeing a Wi-Fi access point in Wireshark which has the name Anup Gupta. So basically when you start your cell phone and search for Wi-Fi networks, these are the possible Wi-Fi networks that you will actually see in your cell phone populated list, right? And now I will just explain what are the other parameters here. Now you may say, why are we not able to see so many here? Because what happens, as you saw, this channel number was dancing between 1 to 13, right? So let's say there is a beacon frame which was sent on channel number 6, and at that time you were on channel number 4. So obviously Wireshark will miss that beacon frame on channel number 6, right? So that is the reason. It's just like, for example, there is a cricket match going on and you are watching a movie. So by the time you are watching the movie, you will miss all that has happened in the cricket action on that particular moment. Similar to here. So let us see first so that we can understand. So beacon, basically what happens here is like, for example, beacon frames. Let me just filter out this. So how do you filter out? Come in the details in the bottom window. So you can see this is a type subtype beacon frame. So for the beacon frame, just right click on apply as filter and just to select it. So now it will only select the beacon frames which have appeared in the network, right? So these are relatively less beacon frames because it is actually capturing for all the stations. So these are less beacon frames, but usually what happens, let me just show you in the Wireshark detailed view. All right, let me just show you in the detailed view. See, you can see this beacon interval. So beacon interval here is 0.0256 seconds, right? So what does that mean? Every 0.025 seconds, a beacon frame is being transmitted into the air, right? So it means every 1 second, there are 4 beacon frames that are traveling into the air. So this router is having a high beacon interval. Usually the routers are configured to have a beacon interval of 100 milliseconds, right? What do I mean by 100 milliseconds? That means the router basically will send the router will send 10 beacon frames every second, right? Now just imagine 10 beacon frames every second. So let's say if you have 6 router in your Wi-Fi vicinity in your quarter, and every router is sending a beacon frame every 100 milliseconds. So in 1 second, basically you will receive 60 beacon frames, right? 10 for every router and 6 routers are there, so 60 beacon frames, right? So basically beacon frame also contains whether this network is encrypted or not encrypted, or it's an open network, that we will actually see easily through this. So for example, beacon frames, as I said, is the mechanism by which the Wi-Fi router expresses itself. Okay, I am present. That is how your list gets populated in the cell phone. And now you will say, how does it basically sort by the power strength? Basically, it sends in this fashion. You can see this also arranges by the power, right? The highest power are shown first. So for me, FDP is the strongest, right? Now, what is the data? So data basically is the exchange of data with the Wi-Fi router, right? So for example, if you can see, I have my home router Mayan, right? If with this you can see there are 3381, right? So 3381 data frames are being exchanged with the Wi-Fi router Mayan, right? So it basically captured that, okay, with this particular Wi-Fi router, 3381 packets have been transmitted, right? So this is just nothing but number of packets per second, right? So number of packets sent per second is 30, which is okay, just a statistic. Channel number, right? This is the most important thing. So basically, if you see, my home router is on channel number 4. FDP, the router in which we are interested, is on channel number 6, right? And next is the megabit capacity. So when I say megabit capacity, basically how fast the router is. So basically this supports 270 megabits, right? So megabits is basically when you divide by 8, you will get in megabytes, right? Similarly, my home router is 540 megabits. So when you divide this by 8, you basically get how many megabytes per second is the maximum speed the router can support. Next, basically, is the encryption. So what happens in encryption? So for example, some Wi-Fi routers are basically free to use, so they have no encryption mechanism, and some Wi-Fi routers have protections. So for example, you must have configured your home Wi-Fi router with WPA2, right? So WPA2 is the most advanced and the most secure Wi-Fi technology. So most secure does not mean that it cannot be broken. It still can be broken. But as of now, in today's date, the most standard is the WPA2, right? So as you can see, I have kept my home router as open so that I can just show you that, okay, if your Wi-Fi router does not have any password, it will appear as OPN. That means it's an open Wi-Fi network. What does open Wi-Fi network mean? Basically, it does not require any password to connect to that Wi-Fi network, but it basically is vulnerable, right? So anybody within the vicinity can start this utility and see whatever data you are sending into the air, right? Of course, if you are sending data to an encrypted website, it cannot be seen, but it still basically can leak your data, which is bad, right? So this is the name. So for example, ESSID basically stands for Extended Service Set Identifier. That means basically extended service set is just basically the network name that appears when you click on your laptop Wi-Fi availability or cell phone when you turn on your Wi-Fi, right? So basically this is the window. I will just go through once again. BSSID is nothing but the MAC address of the Wi-Fi router, not your device. It's the MAC address of the Wi-Fi router. Power basically says which router is close to you and having the strongest signal. Beacons again are basically self-advertised mechanism. Basically, it's a self-advertised mechanism by which the router informs the area that, okay, I am a Wi-Fi router, I am present here, right? Data basically is the number of data frames that are being exchanged, number of packets per second, right? Number of packets per second is just the speed. Basically, elapsed time is 4, and when you divide this, right, basically you will get number of packets per second on which channel. See, you can see routers are on channel number 1, 6, 4, 13, 11, right? So in India you will usually find channel between 1 to 13, and if you go to Japan, they also support an additional channel which is channel number 14. Megabits basically says what is the speed of the Wi-Fi router. Encryption, it can be, see, this is WPA. Basically, there are 4 encryption methods here. One is open, basically no Wi-Fi password. Second is web, wired equivalent privacy, which no longer is hardly used because it was completely broken, right? Next came as WPA, which was enhanced version of WEP for back compatibility, and WPA2 is the standard which is being used these days, right? CCMP is basically the encryption cipher suite, right? So again, this can be as TKIP or CCMP. So let us not go into the details. CCMP basically makes use of AES, that is Advanced Encryption Standard, which is the latest standard basically that is providing the highest security, right? Authentication is PSK. PSK basically is personal security, right? So personal, and you have enterprise also. So at my IIT Patna faculty quarters, everybody will have a PSK. But if your organization is having an 802.11x, 802.1x security, this will be the enterprise security. Fine. So I hope you basically get an idea. Okay, when you have a Wi-Fi transmission, basically what happens and how things are happening, right? So let me do one thing. Let me just airmon ng. I am just stopping my interface. So basically wireless TPS0 mon. Oh, it is PT, right? So now you can see monitoring mode is disabled, right? So why I disable the monitoring mode? Because see, basically whatever I will do the hacking on this particular FDP, And if you can see, this particular FDP is on channel number 6, right? Since it is on channel number 6, I will direct my monitoring mode to only monitor channel number 6. So see WLP3S0, and I will write 6 here. So when I write 6 here, basically I mean to say that, okay, please monitor only channel number 6 here, right? So again, the same command, just I am adding the channel number here, right? And now we will again do arrow dump, right? And now I can filter by channel number 6. And what is the interface name? WLP3S0. And now we have to start the monitoring, right? So now guys, you can see this channel number 6 is kind of static here. It is no longer dancing, right? Last in the case, it was just hopping around 1, 2, 3, 4 up to 13, right? It was hopping around. Now it's not that case. Now I have told AirDoDump that, okay, we need to monitor only channel 6, right? Basically, it's just like a target. Okay, now we are targeting channel number 6, right? So this is just a bug, so that you can see this channel number 4 has appeared, just a software bug which we can ignore, right? So now you can see the beacon frames are huge. You can see this number getting increased just every second. As I said, the beacon frames are sent every 100 milliseconds by default. So you can just see at every second the count is roughly increasing by 10, right? So now let us do one thing. Let us close Wireshark, quit without saving, and now again restart Wireshark. I hope it shows. See, with the Wi-Fi networks, you have to try a lot of times, right? Why? Because Wi-Fi is a lossy medium. Since it's a lossy medium, you need to repeat the experiments many a times, because sometimes what happens, because of too many packet transmissions in the air, the Wi-Fi packet might be lost, right? So let us see. See, now this source is coming as TP-Link. Let me just stop this. You can see this source is coming as TP-Link. TP-Link is my Wi-Fi router, the FDP one, right? And again, let us check the information here. So you can see here, transmitter address or BSS ID is 74DA88. Let us just verify. So 74DA88 50 62 60, 50 62 and 60, right? So this is our Wi-Fi router. And now let us just see the beacon frames. I will just show you in more details here. See, beacon interval is 0.1 second. 0.1 second is 100 milliseconds. So in 1 second, you have 10 frames, right? Let me just filter out this frame. Apply as filter, selected. So as I said, Wi-Fi is a lossy medium. So you just see how many frames are sent in 1 second. See, 23.04 was the start of the beacon frame. See, this is the beacon frame. 23.14 after 100 millisecond. 24, 34, 44, 55, 65, 75, 85, and 96. So let us count. It is 359 packet number, and it started with 350 as the packet number. So 359 minus 350 and plus 1, because we are starting the packet with the 350. So exactly 10 beacon frames. So now you understand how many beacon frames are being sent into the air. A lot of beacon frames are being sent into the air, right? And now you can see beacon frames are always sent as a broadcast frame. You can see the destination address in the bottom. Let me just take this up. Okay, some issues. Now you can see. So you can see this destination address is FFFFFF. That means it's a broadcast. Remember, MAC address destination is a broadcast stream, right? So all the cell phones or the wireless device which are compatible with a Wi-Fi network will be able to see this beacon frames. So everybody receives the beacon frames, and then finally what happens? Finally, the list of the Wi-Fi available networks gets populated, right? Now let us do one thing. What I will do, I will try to connect my Wi-Fi device. I have a Kindle here with me. Let us try our luck. So I have cleared the filter. Now I will show you what happens when you connect to a Wi-Fi network, right? So basically two things happen. If you connect to an open Wi-Fi network, it is just a four-way handshake. But if you connect to an encrypted Wi-Fi network, now you saw already that our is a encrypted Wi-Fi network, this FDP one, right? This is a WPA2 CCMP Wi-Fi network. Now let me try to connect this and let us see if we are able to capture our four-way handshake. Like, let me just start the Wi-Fi device. So Wi-Fi is all about, connecting and trying. So let me just try to connect here. Okay, let me also start it here once again. And let us actually save this file, write fdp dot right. So now what I'm doing, I'm capturing also and I'm saving into a file also. So guys, now what happens, see, I'm trying to connect to this particular Wi-Fi router FDP, right, which is encrypted, right? So I will explain you how do we start a hacking session, right? So now just keep an eye here, right? So for example, this timestamp is here, right? There is a blank screen here. This is a blank screen right now. Fine. So now I am trying to connect a Wi-Fi device to this access point, right? Now I'm assuming, okay, there is some user in the network who knows this password and I do not know the password. And that guy is trying to connect to this particular Wi-Fi network. That guy is trying to connect to this Wi-Fi network. Since it's an encrypted Wi-Fi network, there will be a handshake that will be happening. First is the four-way handshake to connect and then a password verification. Password is never sent directly into the frame, right? So it's not like you just capture the packet and then you know the password. Never. It is sent in an encrypted fashion, then we need to decrypt it. So now just keep an eye here, right? You will actually see a WPA handshake that is happening. If it is captured, right? If it is captured, as I said, Wi-Fi, you need to keep on trying. So this blank screen will be replaced by a WPA handshake. Let us see, our luck should basically work. Yeah, see, so you have good luck. You can see this WPA handshake has captured, right? This WPA handshake initially was not there. Fine. So now what does that mean? It means that the arrow dump utility, it means that the arrow dump utility has captured a Wi-Fi handshake. That means you can see this is the same number 74DA88, 74DA88, and then 506260, 506260, right? So basically it says that there is some station which has connected to this particular access point, which is nothing but our FDP, and which has done the password exchange, and I have captured the password exchange. So remember, the password exchange does not directly give you the password in plain text. Okay. So let me just open Wireshark also and try to show you how actually things happen. It will take me some time because there are tons of packets which are being captured. Association request. Okay guys, so can you basically see this Amazon to TP link? Amazon basically is my Kindle. TP link is my Wi-Fi FDP access point, right? So as it's a client server architecture, the Amazon Kindle first tries to connect to the TP link. Okay, the Amazon Kindle tries to connect to the TP link. Fine. So the Amazon basically sends an authentication request. So what do I mean by authentication request? Basically, it is just trying to send that, okay, I want to connect to you. So you can see this authentication system, the sequence is 1. Basically, the start sequence is 1. Upon receiving that, as I told, Wi-Fi is a lossy medium. So you can see between these two packets, you can just keep an eye here. There is no R return here because that was the first packet. It did not receive the acknowledgement. So basically, it again sent the packet. You can see now R bit is set. That is nothing but the retry bit is set. Right? Frame is being retransmitted. Again, retransmission failed. So it again sent the packet. So basically, it's like an authentication request packet that is being sent. Authentication request packet. Now, after that, what happens? This TP link replies to this. So you can see the source is now TP link and destination is Amazon, right? So now what it is sending, you can see the authentication sequence is 2 because this is the second frame that is being exchanged, right? And let us see whether it is successful. It is successful. So authentication successful does not mean it's a password. So this term is wrongly used by IEEE, right? So authentication is just like, okay, this MAC address is not blacklisted on the Wi-Fi router. What happens after authentication? We see that we do a, after authentication happens, the third step is the association request. So you can see this association request here. So the third step is association request. And finally, which is followed by a association response. You can see this association response. So now you can see association response is sent by TP link to the Amazon Kindle. So basically 4-way handshake happens. Kindle sends the Wi-Fi request to a router, that is authentication. Basically it's an authentication request. The Wi-Fi router responds with an authentication response. So both are tagged as authentication only. They don't tag as a request and response, but internally they mean like this. Then we have association request, which is again sent by the Kindle. Association basically is required so that you can access the internet. Only authentication is like the first step. After association, you are able to access the internet. So for association request, there is an association response, right? So who sends the response? The router basically sends a response to the Amazon device. After that, you can see, since this is an encrypted Wi-Fi network, you see this TP link is sending a key exchange. Key is message 1 out of 4. Key is message 1 out of 4. So again, a 4-way key exchange happens. So you just see. Can you see this key exchange? Key exchange message 1 of 4, key message 2 of 4, key message 3 of 4, and key message 4 of 4. Right? So the way I am linking the Wireshark to this, so for example, when your AeroDump was able to capture all the 4 key exchange, when your AeroDump was able to capture all the 4 key exchange, it basically enables this thing. Okay. There is a particular station, we do not know the name of the station. There is a particular station which has connected to this particular Wi-Fi network 74DA. You can see this. Basically, TP link is of that station. So let me just do this. The destination was 74DA, right? So when all these 4 key exchange happened, right? Since we are lack on time, I'm just going through a bit fast. I know it is too much of information in too less time, right? So basically you can see once I captured this, all the 4 key handshake, right? So let me first tell you, because I know the password already, which is Joker1234. I just want to show you that in none of the key exchange, you can directly get the password. See, this is the authentication stuff. So you can see there is only MIC and some nonce and key and all those things, right? Even if you see in the key information, there is no Joker 1, 2, 3, 4, right? The point being, you cannot directly obtain any information in the key exchange. In all the 4 key exchange, you cannot obtain the key information, even in key message 2. See, this is like a challenge response system, right? We remember in India that the famous Hawala example where you tear a note the half note is with the guy, the other half is with the other guy. So even if when both the guy do not know, they join the note and they check, okay, this is the note is being joined. So basically the party is authenticated. Similarly, during this four-way key handshake exchange, key 1, key 2, key 3, and key 4. During this four-way key handshake, what basically happens is information is exchanged, and then both the Wi-Fi router and the client, which is Kindle in this case, are able to determine that, okay, I have the key and now I can access the internet, right? Now, how do you crack a WPA2 password? So for cracking that, as you know, in the last time I had saved this, right? I have saved this particular capture file. So you can see this particular captured file is saved, and there are of course various utilities. Okay, let me just check for aircrack ng. Okay, just let me do a history grep aircrack, right? Okay, so I need to specify a password file here, right? So I already have a password file. Let me just do a cp. So these password file you can actually easily open online. So let me just show you. I already downloaded this file. You can just see the head of it, right? So in this password file, if you just see how many lines we have, right? So it has basically 10,000 password, right? You can easily go on Google and just type password list, right? So you can see here on Google, you have 10 million password list file. Let me just click here, right? So it's an 8 MB file, and basically it has 10 million password list, right? So it has a 10 million password list. So as you know, you must have read that please don't keep easy passwords, please don't keep easy passwords. It is because of list like this. You already have 10 million, right? That is 1 crore, right? 10 million password lists are already available with you, and then you can try brute force attack on this. So why WPA is secured? Because you can only do a brute force attack. Brute force means you just can try and try and try different combinations, right? So let me just show you how this happens. So let me just take care of the command. Okay. Okay. So the command basically is the aircrack ng suite, and you specify the capture file that you captured. So I tell that, okay, this capture file has a possible password into it. And we also need to specify a dictionary file, right? Dictionary file means in this dictionary, there are 10,000 passwords, right? In this dictionary file, there are 10,000 passwords, and you try all these 10,000 passwords to try to crack the password in this particular capture, right? So now it says, okay, I have read all the packets. Now it says I can sense there are two Wi-Fi networks in this. One is Mayank and one is FDP, right? So which network do you wish to crack? In our case, it is the FDP network, right? Right. So it will basically scan through all the 10,000 passwords, and now you can see the key is found. The key is Joker 1234. Now you may ask, sir, you already know the password Joker 1234. Yeah, which is correct. But what happens is, like, in case I am on an unknown network, right? In case I am on an unknown network, so what will I basically do is I will just keep on capturing the packets, right? I will just say, okay, I want to hack the FDP network. I will just keep sitting here and wait for a client to connect to me, right? The moment a client connects to me, right? As you know, the FDP handshake, right? Where do you see this? In this particular moment, you will see that it is being captured. So let me again try to connect. Okay, so as I said, sometimes the packet are not successfully captured, right? So basically you can just wait here and for a capture to happen. enter again. Let me just enter. Let us try once again. Joker 1, 2, 3, 4. Yeah, see, it captured again, right? So once it is captured, then you just try to get some 10 million passwords online and then just try to hack into the Wi-Fi network. So hence for your home also, please try to keep a complex password having random characters, symbols, small case and uppercase, so that the rest of the combination becomes tougher, right? So it's 12:01, I think. So I just had 1 hour. Sorry for the start delay, or else I would have explained you more and more details of how the things actually happen, right? So you can see this FDP capture which I had done, fdp.this.cap. Cap basically is a capture file. So in Wireshark, you can just see how many packets it has. It has 805 packets. So let me show you that it will have all the e-exchange. Let me just scroll down quickly. See, e-messages 1, 2, and 3 or 4. Right. So now you may say, why there are so many messages? As I said, Wi-Fi is a lossy medium, so sometimes the packets are retransmitted. Right. So when I arrange this, you can see this. Okay, let me just clear this. So key is 557. Okay, it's spread across. So 557. 557. Yeah, see, key message 1, acknowledgement, key message 2, acknowledgement, key message 3, and key message 4. Right. So I think in the interest of time, you can put your questions in the chat window, and I will try to get back to them, or you can just contact me on your email ID. So there were other sessions also. I mean, I could have shown much more details of what actually is happening behind the scenes, right? So this was just more of a command base. So ma'am, I am done. So any doubts or queries can be taken right now, or maybe on offline. I would be happy to answer. I hope you like the little session, because it was all hands-on. I don't have a PPT.
Okay, thank you, sir. Thank you for this wonderful session. So we request our participants to please post your queries in the chat or Q&A section, or in case if you want to directly speak with the expert, you can let your hand raise. We will unmute you from our end. So we will wait for a couple of minutes for your queries.
Sure.
Yeah.
Acha, ma'am, I will just send you a link. Acha, the number which you called. Okay, I will just try to post a link here for the feedback. Right. So is it okay? You can share with the participant.
Okay, sure.
Yeah. So just let me try to get.
However, there will be an overall feedback session of the entire program. So all participants are requested to please fill up the feedback form. The feedback form of this program will be active tomorrow.
Okay.
Yeah, there is one announcement from our end. So dear participants, there will be quiz 2 of this program today from 2 p.m. onwards. So we request all the participants to make yourself available and try to attempt the quiz. Thank you.
Okay. Okay, so I have sent the feedback link on the chat. Just a 2 question, right? I don't have a very long feedback form, just a yes, no kind of. It hardly takes 10 seconds. And thank you, ma'am, from IIT Guwahati for the excellent organization. Everything was quite well planned. Just this Ubuntu has this issue always, and not only with you, with every institute which I do, I had to make this kind of arrangement only.
Yes, sir.
email.
That's why we prefer Windows for the
But
FDPs.
you know, yeah, actually in Windows you cannot do all these hacking stuff. This is only possible in Linux. But nevertheless, it's okay. It's at least people can see the commands and all those things.
So, dear participants, we request you to please fill the feedback form provided by Mayank sir. And also, we request you to please post your queries related to the session in the chat box. So, one participant, Mr. Sudhir Sharma, is saying, when will be the quiz? Okay, so as I announced earlier, the quiz will be from 2 p.m. onwards, as per the schedule. Thank you.
Okay, then I think there are no questions. So
Yeah, absolutely. So thank you, sir. Thank you
yeah,
for joining. So on behalf
yeah,
of the principal coordinator of this program, Professor Ratnajit Bhattacharjee, sir, from IIT Guwahati, I thank you, sir, for accepting our invitation and coming on board and sharing your knowledge with all our participants. So thank you, sir.
thank
Thank
you.
you for joining.
Yeah.
So dear participants, so next session will start from 12:30 onwards. So we will have a 20 minutes, a 23 minutes break. So again, there is one announcement from our end. Please note that the quiz will be from 2 p.m. onwards. So you need to attempt the quiz. Please note that there will be no auto submit option in the quiz. You need to manually submit and answer all the questions. Thank you. Thank you all. Sir, the quiz link will be active from 2 p.m. only, sir. The link will not open. Quiz 1 link is already closed. And quiz 2 link will be open from 2 p.m. onwards only. And please note that the quiz won't be repeated. The link will be active for only 60 minutes. That is from 2 to 3 today. Thank you. Good afternoon, Rishabh sir. Can you hear me?
Ma'am, I can hear you. Good afternoon.
So we have made you the presenter in the meeting.
Okay. Yes, ma'am, I got the access for sharing.
So welcome, dear participants. So on behalf of all the organizing E and ICT academies, I welcome you in the second session of 9th day of this 2-week online faculty development program on Internet of Things. So this session we will be carrying out the hands-on session 8. So Mr. Rishabh Kumar will be carrying out this session. So I request sir to please start. Over to you, sir.
Okay, thank you, ma'am. Today's hands-on will be IoT-based flood monitoring. So this is the hands-on we are doing. Building a device which will measure the water level and send data to cloud and detect the flood scenario, like what is the water level and how we can detect and predict the flooding. So these will be some sensors which will be deployed across this region and cloud. So today we will be also using Peak for uh, doing the visualization part, and we're using some sensors, our node MCU board. So the hardware will be same as yesterday. So as we all know, the flood is a major disaster and it causes a huge amount of loss in terms of environment and life, living beings. And this is the early alert also very much crucial in mitigating the losses and the damage which is caused by the flood. So the objective is to sense the river bed, and we will be using an ultrasonic sensor to do that, and a node MCU to send data to cloud. And we will be using ThinkSpeak IoT Cloud, what we used earlier in the session, and we will send data and monitor that what is the water level. So in a real scenario also, there are small sensors which are deployed in field. They have a ultrasonic sensor. They call it as a radar gauge. And what it does is measures the level of a particular liquid or any surface. It just measures the level of the surface and it sends data to its base station or its corresponding control room. Flooding impacts a lot, like flooding. There is a in like areas which are near the river or which experience a very heavy rainfall. They tend to be always have a flooding, and the proper, because we cannot stop flooding, but if we plan of our resources very properly and if we have early warning, then we can move people around and properly manage the scenario. So here a lot of life, always people get trapped in their house by, if the water is rising very quickly, they don't have ways to escape. All the roads are flooded, so they cannot go outside. So that's why there is a huge risk of a death or injury, and also the property laws allowing properties which are flooded, and it completely destroys it. And the pollution, because it's also all the water is now coming to your home and every drainage system is just blocked. So all this it cause the pollution also, and destruction of wildlife also destroys the wildlife of the river also, and other living creatures like dogs, cows. They are also very affected by the floods. And there are some more laws, like because it impacts our infrastructure also, and with this, there is loss of the basic infrastructure like water, electricity, transport, communication, education, and healthcare. So it also gives us long-term losses. In terms of short-term losses, it also has its own long impact. So, and again, there is a loss of livelihood. So, what is the benefit of the flood alert? So, like flood warning is a provision that it advanced warning of condition. Like we have the data. Let's say we have a data of a riverbed. We have a data from the weather station. We have the weather forecast, and we know how much rainfall can be in the field. What are the wind condition? What are status of the rainfall in other regions which are connected to this river or this river or something, this stream of water, and all geographical location, like which are the higher one, which are the low one. So we have all the data. So once the we have data, then we can plan it that how we can minimize the damage. And also it helps in the timely operation of flood control systems like temporary making temporary gates, temporary dams kind of thing. So like making boundaries across the region to protect it, and also remove relocation of the property or the assets which we have to the above the flood level. Let's say we can rise this level, because we always measure from the sea level. All the height will be we take the sea level as a reference. So then we know that with this height there will be a chance of flooding, so we can move it to more higher locations. And also the overall benefit is the reduction of losses. Like government of the plan a way that we have to reduce the losses. So here is a diagram. Here is a small sensor. It is deployed. It has a rain for measuring for rain. Also, it has a solar panel, so it can be powered by itself. And also, it has this sensor. If you are able to see that, this is the sensor, and this sensor is an ultrasonic one. What it does is sends the sound signal, and once the sound signal hits the water level, it bounces back, and then it calculates the time between the send signal and the receive signal. Then it got the exact distance, that what is the distance of the object, and we can calculate the water level. And with the change in the water level, the time will be lower if the water level decreases. Okay. So can anyone confirm like someone is facing issue like they are unable to see the slide moving?
Yeah,
So,
hello.
yeah,
Yeah, slides are like, yeah, slides are absolutely fine. It is clear. Like secure mounting, perpendicular, these things are displayed, right?
Yeah. Because someone in chat sir has mentioned that maybe it is not moving. Maybe some network connectivity at your end may be there. Okay. So this is the overall arrangement of a sensor. And what they will do, they will send it to if they have an addition, then it can also work. So in this, LoRaWAN network is very much preferred because it's a very long range network. So please deploy small LoRa based sensors because they will consume less power, and they can be a long game, like we can achieve a
Yeah, Rishabh, we can't hear your voice.
okay. Now I'm audible, ma'am.
Yeah, now you're audible.
Okay, actually it's mentioned here like I have some network just checking out. Okay, so we will be for this scenario, LoRaWAN and the RF are best. We can GSM have its connectivity and its urban area, so we can use a GSM based device also. But for our experiment, we will be using Wi-Fi because we will be using the same node MCU that we used earlier. So today we will be using our node MCU, which has a ESP8266 set, and it's a Wi-Fi only, and we will be using the same uh, IoT board, and it has a built-in ultrasonic sensor. Let me show you. So this is the board we are using. I have shown in the previous session. So here today we will be using Node MCU, the ultrasonic sensor as a level sensor, as a radar. We can in industry we also call it as a radar gauge. So it works as the same. It sends the signal and receives a signal, and it's a sonic sensor. And here it will be using OLED to display the um, centimeters, like what is the level. So this is and then we will be sending from here you then two things speak loud.
Rishabh, your voice is
So what
breaking.
is the current situation? How current? Okay, let me check the internet map once again.
Rishabh, we can't hear you.
Am I audible? This is still breaking. Okay, ma'am. Let me change.
Hello, Rishabh, we can't hear you at all.
Now, is my voice clear, ma'am? Now, I have just changed the Wi-Fi network.
Okay, okay. Now
Am I
it's
audible?
clear. Yeah, now
Okay.
you're audible.
Okay, ma'am. So let me share my screen again. Now my screen is visible, I guess.
Yeah, absolutely visible.
Okay, ma'am. So what is the current system that we are talking? So currently how this thing is done, like how this flood warning and early warning systems work at and what are the approach that government takes in detecting the flood. So basically, from what happens when the water rises, keep on rises, then they make some bases. They make some bases like base 1, base 2, base 3, base 4. They make the bases, and they will have the people there, and there will be a marker like this is the 400 feet, 500 feet, something like that. They have the markers in the river bed, and from there they will take the reading and report to a control room. And then what happens in the control room? Control room have a matrix data that on they have the water reading that the water is the 400 feet above sea level, 400 meters above sea level, or any kind of data. So they put in the matrix, and then they will calculate on the basis that this much area will be affected. So accordingly, they generate a warning like for this 10 areas, it will be a red alert. For this 6 areas, it will be kind of a yellow alert or some moderate alert, and for the other areas it is now fine at this level. So it's a manual process, like on every base there is a 1 or 2 persons who are continuously monitoring the water level, also the rate of change, rate of water increasing, like it is increasing by 1 feet per hour or 2 feet per hour. They also calculate the exact water level and the rate of rise of the water level, and then they report back to control room, and then the control room will map with the already they have the geographical data, and with the geographical data they map it uh, on their matrix, and they will show the result. Nowadays they also upload the data on some system, and we can also view on the app also, like what are the in flood scenario, what will they have a app or a portal, so we can also monitor that what is the current status of our location, or what is the alerts that are issued by the government. But currently the collection of the data is not automatic. So components that we will be using, so we will be using a ESP8266 node MCU, an ultrasonic sensor, OLED display, and a power supply. Of course, we will be powering it with our USB cable, and this is node MCU learning kit. This all be populated on the node MCU learning kit, and then we need some jumper wire. So this is a simple working diagram. Here we have HCSR04 ultrasonic sensor ESP8266 node MCU board, and we will be sending data to ThinkSpeak using HTTP REST API, and we will be displaying data on the OLED displays. So this is the ultrasonic sensor. So it is a HCSR04, and some we can also call it HC04. And it's the ultrasonic sensor. It has 2 pins. One is a trigger, and the another one is a echo. And it can be powered from 3.3 to 5 volts. So from one pin we send a signal, and the another one receives the signal. So basically it sends an ultrasound wave, and it just go on the surface, and then it reflect back. And by the calculating the time, because we already know the speed of sound in the particular medium, which is air here, so we can calculate the distance between the object. So here is an example of working the one dome is the one dome, which is a transmitter. This one is a transmitter, and this one is a receiver. So from here we send a signal, it just hits the object and then it gets reflected back, and then receiver sends it, and then we get this on the trigger. We send a trigger pulse and then we got a echo pulse. So we detect the pulse, we send us some signal and then we detect the signal back, and we use a timer to calculate the distance between these two pulses, and by using a formula we can calculate the distance. So here is a simple formula, and we have to divide it by 2 because the time it takes from sending and receiving. So it takes twice the time. Once it travels to the object and then it hits and then reflect back. So it takes the twice amount of the time. So we divide it by 2 because it covers, sorry, not the twice the time, it covers the twice the distance. So here are some features of HC04. It's a 5-volt working and consumes 15 milliamps of power when we send a trigger pulse. And the working frequency is 40 Hz. Then the measuring angle is like 15 to 30 degree max. But for after 15 to 30 degrees, it won't the reflected signal won't come to this receiver. So the angle of the object should be maximum 15 to 30 degree. Otherwise, they will reflected somewhere else and it will be not picked up by this receiver. Or it can be some reflected signal which can be picked by the receiver. And in that case, we will be getting a wrong data. So participant, any questions till now regarding this ultrasonic sensor? And how many of you have created a ThinkSpeak account? Okay, there is one question. Which layer of IoT is more vulnerable to security issues? It depends. Okay, it's an older question. Sorry, from the another session. Okay, so how many of you have created a ThinkSpeak account? Because today I will not covering how to create a ThinkSpeak account. Am I audible?
Yes, you're audible.
Okay, so please let me know in the chat or on the Q&A that you have created your ThinkSpeak account. Okay, so next we will be using a OLED display. Because we also want to see the data in real time also. So we will be using a OLED display, but display is completely optional. Like without display, this project can also work. So the only basic components we need is the ultrasonic sensor and a ESP8266. So basically, OLED is different from the LCD. Like LCDs have the backlight, but OLED, the pixels emit the light, so it doesn't need any kind of a backlight. And because the pixels can turn all the way off and all the way on, so it can be a deep black and a deep white. So it is a more the color experience is more, but we will be using a monochrome display, so only we can see the blacks and the white only. And we will be using a 128:64 OLED, but you can easily get a 128:128 display also. And this is a simple dot matrix display. So, and with the best part with the display is like we can put a graphics also. Because earlier with the 16x2 early displays, if you are familiar with, these displays can only be a character display. So it can be a alphanumeric display, I can say, where we can only put an alphabet and a numeric values and with some special characters. But we cannot display the graphics because they are the alphanumeric displays. But for with the OLED display, we can display a complete graphics because it's a pixel display. So we can, with the help by turning each pixels on and off, we can display a particular image. Like here you can see we are able to display a complete picture. It's a monochrome one, but still we are able to display this picture. But we won't be able to do that on a 16x2 display. So here are some of the 16x2 displays, like based on the color, based on the size, based on the controller IC. Because some uses SSD 1306 and some uses the SSD 1331. So, and based on the pin, like they have the both interface, like these LCDs can be, sorry, these OLEDs can be communicated via the I2C protocol or the I2C and SPI protocol also. So here, they come in a blue one, they come in a white one, and they come in a yellow one. They are also colored one also, like they have some strip of blue, some we can configure the color also. And then there is a shape and size, like they come in various shapes and size, like it's a nearly a 1-inch display or smaller as 1-inch display. So whatever fits our requirement, we can use that. And it uses chip on glass technology. It has a chip built in on the glass. So from there, this chip is built on the glass itself, which controls each of the pixels. And this PCB is just a mounting. It is just for the mounting. The whole display assembly is this one. This only the glass, and it doesn't need any kind of backlighting. So there will be no LEDs or backlight under this. But the one of the major downside of the OLED displays is like it relies on their intensity of the pixels. So if we plan to use them outdoors and we don't have a very good brighter display, then they will be not as effective as a reflective LCD displays, which is a 16x2 display, because it naturally reflects, because it have a reflective layer below the LCD. So it just reflects the characters. So in highlights, it will be more easy to see a So today we will be using our display which has I2C interface. So I know everyone is familiar with the I2C interface. So they have a 2-pin. One is a STA, serial data, which is used to transmit data between master and slave. One is a clock source, clock signal. It used to carry the clock for the data line, and one is a VCC, and another one is a ground. And it's a 3.3 volt display. So if we give a 5 volt, there is a high chance of damaging it. The logic level and the power supply, both it takes the 3.3 volt. And then there is a ground pin which is connected to ground. So now we have to install the libraries for this OLED display. So any doubts or any questions till now? If you have any questions, please ask in the chat box or in the Q&A regarding the OLED display, regarding ultrasonic sensors. because the ESP8266 I already covered in the previous session, so I'm not covering that. So any questions are till now? Okay, so let's move to installation of the library. So I earlier told how to install a library. Like we have to go in the sketch section, then we have to go in the include library, then under the include library, we have to go through manage libraries. Then we need to search for the driver which is present in the chip, which is SHD1306, and we will download the one library from the Adafruit one. So we will be downloading library from the Adafruit here. So we will be select here and we will be installed. But if it is already installed in the system, that's why it's showing installed. Let me show you. If I open Arduino. So in the sketch section, we will go and click on include libraries, then click on manage library. And we click SSD1306. And you see, we have installed the library for the SSD 1306. We already installed the library for SSD 1306. And after that, we also need to install the GFX library. But we won't be using this, but I will. You can install it to view some graphics or any. If we want to view some graphics or other patterns or images and text, then we need the GFX library. So they have the built-in some built-in graphics which can be used to work on the OLED display. So we will be also using the Adafruit GFX. The process is same, like we have to again go in the include library, go in the manage library section, and then we can include it from here. And you can see I already installed the Adafruit GFX library. I have already installed it. And here is the connections. So it connected to D1 and D2 pin, which is GPIO 5 and 4 to the node MCU, and here is the OLED one. Let me show with my camera. So So here is a node MCU using the same IoT board. Here is OLED. So it is connected via this D1 to pin to this is the OLED we are using. And here is the ultra sensor we are using for the level sensing. So this is the setup. And here is the overall diagram. How we wired up the ultrasonic sensors, how we wired up the OLED display, how we wired up node MCU, and we also wired up two LEDs, which I'm not using because I'm already displaying the data on this OLED display. So let me show you an example how to display a graphics. If we download any library, let's say there will be question that how we get started with the libraries or that we installed, or how we know that what will be the library function that will I need to call. So we can go in the example section from here, and here you can see I have all the examples of all the libraries that are used. So here you can see I have a library for Adafruit SS1 1306, and here you can see I have the I2C version SS example. For this I can run it from here. I can click open it, and here there is some sample code, and it is displaying some pixels, like it is displaying a draw line, rectangle, and everything. It is drawing from here. Connect the board. Now COM port is detected, and I will hit upload. Now it's compiling. And now you can see the code is uploaded. So I uploaded the code. I have to check for this address also. So once we get the address, we can just upload, put some graphics here. So this is how for any example, like if you want to learn, like if I have the ThinkSpeak. So for ThinkSpeak, I have this, and we can use to read and write. So all the libraries, any libraries which we install, they have their own examples. So we can learn from the examples also how to use the library. So let's move to ThinkSpeak Cloud again. So I will be not covering how to make a account, because I already covered. So first, we need to install the ThinkSpeak library. Because earlier we in our earlier code, we are using just a crude method to send a HTTP request via using the barebone TCP, and we are making the packet by our own. But today we will be using a ThinkSpeak library, which is again by the MathWorks itself, and then we can just call the function simply to upload our data values. So again, we have to go in the sketch, then we go to include library, then we have to go the manage library. Okay, so there is a small question, we have to plot a ECG sensor data on OLED display. Yes, it can be done with the help of our GFX library. We can easily plot the data on the OLED, and also if we want to send a doctor to the in a real time, then we need to use some kind of a connectivity like a Wi-Fi one if we want to send it over the internet, or if we want to send it over Bluetooth, then we need a BLE. But yes, we can send it over internet also. So just we need to time speak. So I already installed. We have to install this ThinkSpeak by MathWorks. We have to install the library ThinkSpeak by MathWorks only. We don't need to install the another one. We have to install the official library, which is ThinkSpeak by MathWorks, and then we can simply include the ThinkSpeak. So we have to install the ThinkSpeak library. Okay, so once we install the ThinkSpeak library, then we again have to log in our ThinkSpeak account. So to create a channel, we need to create a separate dashboard for this experiment. So let me go to ThinkSpeak. Because I already logged in, it shows me straight the channels. It shows me channel, but if I have log out, it shows me to log in. I think everybody know how to log in into the ThinkSpeak. Or should I repeat one more time? Like I can repeat quickly if you want. If anybody faced are not able to follow on the previous section, I can just simply quickly go through and explain. So if anyone have problem, they can ask in the chat or Q&A. I will just quickly explain the ThinkSpeak. Okay, so we have to go here, like on the ThinkSpeak website, we have to click on the Get Started for free. So here we need to create an account. Because we don't have, we have to create an account, and you have to follow the steps, and then you will be able to create an account. Then you have to verify your email. So they will send you an email, and you have to verify that email, and after that you will be able to log in with the password. And then it will ask you a couple of questions like for what purposes you are going to use and what is your project name. So this is, yeah, if you already have a MathWorks account, you can simply log in with your MathWorks account and it will work. You can just simply log in with the MathWorks account. It will work. So here you can see yesterday's project is already there, but we need to create one more project. So to create a project, because projects are channels here, so I will create a new channel. So just go. And because there is only one level, which is the water level, so we only need one field. And we can also, in our case, the latitude and longitude can be also used, like we have to show from which location the data is coming. So we can just simply click the latitude and the longitude of our coordinate. So let me check what is the latitude we can put. So it will display a map data. Okay, here is the coordinates. Copy this, but leave it for now. But yes, we can add that location also, and it can help. But for now, leave it blank. And we just click on the save. But on your channel, you can experiment with it. And here you will see the water level. We got one chart for the water level. And now we will add more widgets. I will explain the code later. So here we have to add a widget. So I will add a numerical display to display the level of the water level. We have to take a numerical display. From the widget, we will add a numerical display to our channel. So we have to go again in the widget. and then we have to add a numerical data display, and we will be also using an indicator. So we have to click here on the numerical display, and we have to make a numerical display. And then here the units we can put like meters. Although the sensor is reading in the centimeters, we are putting it as a meter. Then hit on create. So it is created in the private view. For the public view, we also have to create, because it is a two dashboard. I already shared you a public dashboard. So for that, we have to go again in the sharing, and we have to just share the channel. And now the channel is shared. And from here, we have to make a public view also, because private view only I can see. So in this, we can have a public view also, private view also. So we have we can choose how much data we want to show to public entities and how much data we want to in a private view. So in a public view also, I will add a widget similarly, and then unit says meter. And I add water level, and I will hit create. So now the water level numerical value is created for the public as well as private. Okay. So now we will again add a widget. So I will add a lab, like it will show a critical solution. So what is the status? Let's say if I have a distance that water level is like 20 meters, 30 meters. So and it is close, and it is the distance between them is reducing. So it will give me an alarm. So what if the lamp will just light up? So lamp is just an indicator, and we can specify the color or which it will show. So first I will add in the public private view, and then I will add in the private view. Sorry, public. Let me add in the public view only, because I will be sharing the public view with you. So we have to go in the widgets, then click on the lamp indicator. And here we can put the condition. We can put multiple of them, like if we have to issue a green, if we have to know yellow, green, we can categorize this in also, like we can have a yellow, red warning, yellow warning, and healthy system. So I put a 5. If it is a 5 meters, only because we are reading the distance, so we have to convert it in the levels also, because for here, the smaller the distance, the higher the water level is. So the change, I can change it to red. And here is a lamp, and I will again add one widget more, again a lamp, and if it is greater than 10, let's say 15, then it will be green. Add one more for yellow for the intermediate condition. I'm not able to find. Let's make only two conditions. So here is our two alert status. One will be for the red alert, one is with the green alert. And let me share this channel to you. I'm pasting it in the chat section so you can access, see on your own screen. I send you a link. Please check if you are able to access the dashboard. Please confirm in the chat or in Q&A that you are able to, you got the link which I shared, and you are able to open the dashboard. Okay, so now we created this lamp indicator. Then we are in this library, because we are using the library, we need the channel ID and the and our API key. Earlier we are only using the API key because we are using a more crude method to create a REST API, but it will create a REST API for its code. So if I show you the code, I just included a thingspeak.h library file. And if you go in the code, it is a much simpler. Like I only have to set a field and then write out the field. So I only need to call these two APIs, like two functions, thingspeak.set field. Then I will set the field one as a distance, and then I will write the data to channel number and the with the help of this key. So we don't need to write the code which we earlier write. Let me show you the earlier code from the yesterday session. If I open it in the notepad, here you can see what I'm doing. I was making this whole HTTP manually. Like I'm printing this post update HTTP. I'm making this header. I'm using the API key, putting manually. I'm putting the API key manually, and then for making the whole string, I'm just posting the whole string. Send the complete string. But we are not doing here. Like here, you can just see. If you go, I'm just calling these two functions, and we have the tutorials example is for this also. Like if you go in the ThinkSpeak, it has for the ESP32, it has different example. ESP8266, they have different example. And for Arduino, Ethernet, for the different boards, they have the different experiments. And ESP8266, like if it is a program directly, we can read, write multiple field, write single field. They have the examples. So now what I need to do. So anyone else? I got only one reply that my shared channel is visible. Is it visible to any more people? I pasted the link in the chat box. So I have to put the channel ID and the API key. So channel ID is mentioned here. I have to just copy it and paste it to this variable, that is my channel ID. And then I have to paste the API key. So API key I can get from this tab. So I have, because I'm updating data, so I will be using a write API key, and if you are reading data, we will be using read API key. But again, we are only writing the API, writing the data, we will be only needing the write API key. So here in this array, I will just paste my write API key. And then I will have to compile it. Anyone else is able to see my channels in a public view, which I made? There will be no data, but still you will be able to see the dashboard, I guess. So now compiling is done. Then I have to upload a code. We have to check the COM port, and the COM port is correct. My board is connected, and I will hit upload. And now and now if you are able to see, the data is updating. Now the data is updating, like here you can see it's 17, it's showing 17 meters. And because it is green light is there, because the value is greater than 15, then there is a no alert, and it is a healthy. So now it will update the next value, because it has the update interval. Now I have moved my object from there, and here you will see they will be updated, and it is not updated at the same time, because we have changed set the update value, like every 15 seconds we can lower it down. I think they have kept it to 15. In a paid version we can change that, but for here only it's for the 15 seconds. So let me show you the hardware setup. So can anyone from the audience that they are able to see the data also on the shared channel? Please, you can write in the chat section. Am I audible? if you can see on the OLED, the distance, it is a showing distance. I that you are able to see the video. Hello, am I audible or I lost the connection? Can you confirm?
Yeah, actually, your
Um,
voice is little breaking.
okay. And now I'm audible. Ma'am, can you check if my screen is visible and my voice is clear now?
Yeah, your voice is clear, but screen, like your sharing screen is visible. Probably you can stop sharing and
Yes, ma'am. Actually, okay. So now I think the hardware is visible.
yeah, absolutely.
So I shared the dashboard with the participant. So can you anyone from the participant confirm that they are receiving data on the dashboard? And here also you can see it's printing on the OLED also. On the OLED display, it is showing the data like 40, 39. And anyone from the participant can confirm that they are able to see the shared channel, like from here, what I shared, the shared channel, at least they are able to access on their computer or mobile. Okay, so here you can see this is the hardware and this is the ultrasonic sensor and our dashboard is already visible to you. So if I place let's say I simulate a rising water level. So let's say I just put this and you can see the reading is lower because I put my mobile phone in front of it and the distance reading is lower. And now it's close to 5 centimeters. And if it will be less than the 5 centimeters, within a few seconds, you will see the red status light is come on. It means it is a red alert. Are you able to see on your dashboard? Uh, like here, you can also see it's 4 I put a mobile close to it, and it is now you will see the red one is up, red alert is up. If I move it little further, if I move it little further, and once the data is updated, we will see the red will be turned off and green will be turned on. Now you can see the green is turned off, and here it is showing 19, and now the green one will turn on. I think you can see on the share dashboard that green indicator come on, and you can also see that value on the chart also, that it's changing. Here you can see that now it is green, and here are the data points that we have. So for this experiment, we cannot own, it is not only that we can monitor the flood, also it can be used for monitoring the water level. We are using the same technology in measuring the tank level in various industries also, where we use the radar gauges to measure the exact level, and they are very accurate, like they have an accuracy of a millimeter. Even some are accurate to a certain like 1/10 of a millimeter. They are very accurate, and they are used for like all kind of a measurement. Like one project we are doing done is like with IOCL, we are measuring the ethanol tank location, and we are sending it with our LoRa devices to the base station, and we are monitoring the level of the ethanol in the tank in the real time using radar gauges. This works as a similar, it's just a ultrasonic sensor. It has a better accuracy. So you can see now it is green. So participants, any question from this experiment? If you have any question, please put in the Q&A or in the chat, or you can raise a hand so ma'am can unmute you. So participant, any questions or any query regarding this experiment? So this is for today hands-on. If you have any query, you can ask regarding the code, regarding ThinkSpeak, or any other doubt, or any application you want to have in your mind and you want to do with ThinkSpeak, you can ask here. Okay, so let me explain you code, and on the same time, if you have any questions, you can ask me. So here you can see I have included a ThinkSpeak library that we downloaded. Then we have the ESP8266 Wi-Fi headers library, which have the pin maps, which sets all the pin map for it. And then we have the Adafruit GFX library, which is used for the graphics. And we have the driver library for our OLED display. And then we have a Adafruit sensors library. But we are not using the Adafruit sensor library, but actually some components are there from here. They are in the present in the sensor, so we have to include it. Then we have to give the display width and height. So we give the display width and the height. So display width is 128 pixels and display height is 64 pixels. And then we have to specify like what are the I2S DA pin and SCL pin. So it is defined by the wire library. And then we here is the two pins of our ultrasonic section. The one is a trigger pin, the another one is the echo pin. So trigger pin is connected to D5 and echo pin is connected to D6, which is GPIO 14 and 12 respectively. So we can either use these macros and we can simply put the pin numbers also. And then I put my channel ID, it is from the ThinkSpeak. Then I put the right API key. Here is my SSID and the password for my Wi-Fi, which is for testing. And in the setup, you can see I made the trigger pin as output. Yes, this is for the education purpose only. Like if you want to share them update, what you can do, just a basic one, you can deploy some kind of sensor like this one, and you can simply share the this dashboard in the public view. You can share this API to this URL to them, and it will be helpful for you. Like you build some project, your student build some project, and you can just because it's available in the public domain, you just need a URL to access it. So you will get all the data. And here we are also put two LEDs, but we are not using today. And we are now beginning the serial. So it also like prints data on the serial. Let me show you. Here you can see it is continuously printing 39 and 40 centimeters because that's the max range it can achieve. So now we are doing we are connecting to Wi-Fi that by beginning SSID and the password, and then it will print the Wi-Fi connect, and it will begin the ThinkSpeak client. So it will start the ThinkSpeak client by connecting to the ThinkSpeak server. We don't need to specify any URL or any other thing. And after that, we will begin the display. If and the address is 3C. Earlier on the experiment of our contactless thermometer, the address was 5A, but here it is 3C. So if the allocation is failed, it will be in a continuous while loop. But if execution is successful, it will come back. And now it clears the display and set the color to white, text color to white, because we only have a monochrome display. So although if even if we set any color, it will not display. So we have to set the white. Now we have to digitally write on the trigger pin, and we have to give a delay of a 2 microseconds, and we send a pulse, and we are sending a pulse. We are sending a pulse to this trigger pin, and after that we are reading this like we are reading a PWM on our pulse on our echo pin. So I'm taking the pulse pin in and we are calculating the timer duration. And after that duration, we put in the formula and we will get the distance which we are printing. And after that, we get the distance. We can also show it on the display, but this we implemented on our dashboard, so we are not using the LEDs. And we have to set the fields. So we set the things field that we only need the first field is a distance. So we set the variable that distance is the first field. And after this first field, I will simply write to the ThingSpeak cloud that this is my channel name number and this is my API. I have to write and it will send the data to ThingSpeak. And after that, I will continue reading it. So this is for this session. You can ask questions if you have.
Yes, participants, you can chat you can post your questions in the chat or Q&A section, or you can also raise your hand so that we can unmute from ourselves and you can interact in the session. So there is a participant who has raised his hand, so I'm unmuting him.
Okay, ma'am.
Yeah, Valan, sir, can you hear us?
Yes, ma'am.
Yeah, please ask your query.
Apart from measuring the distance and the accuracy, how it is possible to communicate this data to somebody needed or to any departments?
Oh, so like we can simply if we want to have a proper infrastructure, then like we can upload this data to a central repository or central cloud platform which is there or a common platform. Then they can take the data. Like if for example, if I just share this dashboard to a government body or a particular department, like here is the water level that you are getting. I'm just deployed 10 sensors and sending them 10 data. That 10 data point, I have the geolocation, this, and they have the water level these. So they can take actions from there. Or they have some, if they have some infrastructure, they can, or we can make a custom application for them also, if you want.
Okay, sir. If you are writing the applications or the algorithms which gives more accuracy, then the existing systems can also be modified in disastrous situations.
Yeah, just if we have, let's say we are using a simple sensor, but if we go for the more accuracy one that people use like a radar gauges in the industry, they are very accurate. Like I've been using some for the level sensing. Let me show you. And they are like these one. They are very high accuracy, like they are 0.5 millimeter accuracy they have. So they are kind of very highly accurate devices which are used in industry for the measuring purposes. And from here, not only we can get the water level, but we can also get the rate of increase of the water level also. Like this is the radar that is used for the water level sensing in the industrial applications, where we need to monitor a tank or a reservoir water level. I hope I answered your question, sir.
Yes, sir. Yes, sir. Yes, sir. Thank you, sir. Another thing is if we are concerning with the disastrous management, the early warning systems have been located in almost all the states along the seashore, I think. Whether that department or the early warning system have sensors, they are utilizing the same thing or not, sir?
I'm not sure, but yes, sir, they definitely use, like they collect the weather data also, and they are utilizing, but to an extent, like let's say in because I can give you a clear view, because I also belong from a place we live near River Ganga. So more every rainy season there is a rise in the water level. So what the local tehsil, because it comes under the tehsil level, what the government do is like they make the check post. Like they will continue monitor the water level and they communicate to the tehsil where they make a control room for this disaster management kind of thing. And we have one weather station already deployed in the premises of our tehsil complex, and from there they take all the data. They have a matrix under which they issue a particular alert to a particular village or area. They have the geographical data already mapped, like what are the level of the particular villages in the particular region and how they are going to affected with this water level.
Okay, sir. Okay, sir. Thank you, sir. Thank you very much.
Okay. How? Yes, Django you can also use, but it will be like creating your own. If you want to create your own dashboard, you can use the Django platform framework. Okay, ma'am, so this is from my side. If you have any questions, I can take.
Okay, one question from a participant, Pawan Shukla, sir. So he's asking, good afternoon, sir. Please tell me how ECG sensor data seen on OLED display instead of serial plotter tool and sent
Yeah,
it to
ma'am,
the doctor
I
in
think I
real time.
already answered this question in the mid of the session.
Okay, okay. Another one question from a participant is how Django model
Yeah, ma'am,
template
I
view is
answered.
work.
It's in the chat. I answered it.
Yeah, yeah. Okay,
Okay.
okay. So I guess with this, there is no queries from the participants anymore. So thank you, Rishabh, for joining today and making this day's 9 successful. So dear participants, shortly the MCQ will be active. The quiz too will be active. So we request all the participants to please take out some time from their busy schedule and answer the questions. However, all the questions are not compulsory. You can answer those questions which you know. So another one thing is that there will be no auto submit option. So you need to submit it manually by clicking on the submit button. So that's the request from our end. The MCQ link is already provided in the MCQ Google Doc page, which is already uploaded in the Google Drive. So dear participants, the quiz is active. The link is active. So we request you all to please solve the quiz and submit it within time. The quiz duration is of 1 hour from 2 to 3. So Rishabh sir, you can log off now as of now.
Okay, okay, ma'am. Okay, thank you, everyone. So I
Thank
will
you,
be
sir.
logging off.
Thank you for joining and making this program successful. So, dear participants, we request you all to log off from this WebEx platform and please be active in the Google link and solve the MCQ and submit it by 3 o'clock. Thank you all. Thank you all for joining today. Tomorrow tomorrow is the last session. So we will start at sharp 10 o'clock. The link will be remaining the same. Thank you all. So we request the participants disconnect from their end. The meeting link will be deactivated in another 2 minutes. Thank you all. Bye.